post-lunch session of this seminar. So we are beginning the academic session number 2. And in this session we are very happy and privileged to have as chairperson Dr. Amba Kulkarni, Professor and Head, Sanskrit Department, University of Hyderabad, and Dr. Sri M.G. Narasimhan, Chief Technological Officer, Samskriti Foundation, Mysore, and Sri Venkata Subramaniam, Co-founder and COO, Vyoma Linguistic Labs Foundation, and Sri Anish Chevukula, Assistant Professor, Department of CSIS, BITS, Pilani, Hyderabad. So I request you to kindly come on stage and be seated on the dais. So before I hand over the mic to Dr. Amba Kulkarni, I would just like to read out the profiles of the speakers. So Dr. Amba Kulkarni is Professor and Head, Sanskrit Department, University of Hyderabad, and Adjunct Faculty at HSS Institute of Technology, Hyderabad. A topper in academics throughout her formal education, Dr. Amba has over 10 books and several papers, publications, and several conference presentations and talks to her credit. Her research interests include study of Panini's Ashtadhyayi from computational and NLP perspectives, as well as showing relevance of traditional Indian Shastras in the modern context. She has also worked on development of software relevant to the field, such as morphological analyzers and generators for various languages, language accessors, Anusaraka for different language pairs, as well as several other Sanskrit and computational tools. Apart from that, she has been associated with our organization for several decades. So I extend a very warm welcome to you, Madam. Namaste. The first speaker is Dr. M.G. Narasimhan. Sri M.G. Narasimhan is a result-driven, client-facing program manager, training manager whose core competency includes software project management, including project planning and control, risk management, software estimation, cost management, configuration management, software engineering, team management, etc. He has 40 plus years progressive hands-on IT experience on different platforms, from mainframes to web technologies. He is the technical head at Samskriti Foundation. I welcome Sri Narasimhan with a very warm heart. And the other speaker today is Dr. Venkata Subramaniam, once again a traditional scholar and information technologist combined into one. He is the Managing Director, Vyoma Linguistic Labs Foundation. He earned his PhD from Karnataka Sanskrit University for research on qualitative analysis of Sanskrit e-learning systems. He is also a certified project management professional with more than 20 years of rich corporate and project management experience. He has co-founded and is Chief Operating Officer of the world's first Sanskrit e-learning non-profit company, Vyoma Linguistic Labs Foundation. And incidentally, I am happy to let you all know that he has provided an opportunity to me also to teach on his platform. So my about 100 classes on Nyaya Shastra in Sanskrit are available on his website, and it has been a great opportunity for dissemination of knowledge of Nyaya. So I am very grateful to him for that purpose also. His vision is to imbibe science Shastra consciousness in every individual on earth. And Sri Anish Srivallabh Chivukula, I request him to kindly join, or probably he'll be joining us short. Okay. So just now in the morning we had 2 inspirational talks from Dr. CSR Prabhu, and like father, like son, they say. And Sri Anish Srivallabh Chivukula is the illustrious son of an illustrious father, Dr. CSR Prabhu. He has a PhD in data analytics and machine learning from the University of Technology, Sydney, Australia. He holds a Masters of Science by Research in Computer Science and Artificial Intelligence from the International Institute of Information Technology, Hyderabad. His research interests are in computational algorithms, machine learning, deep learning, data mining, adversarial learning, and data analytics. He has work experience in engineering, R&D, academics, consulting, and research labs and startup companies. He is currently in a faculty position with BITS Pilani Hyderabad campus at the level of an assistant professor in the Department of Computer Science and Information Systems. So we have a very elite panel today who will be taking you through this session. And on behalf of Samskriti Foundation and on behalf of you all, I extend a very warm welcome to all of you. And I now request Amba Madam to kindly take over the session and run the session. Thank you very much.
Namaste. Just one clarification, sir, I wanted from you. Dr. Alwar? Okay. Because we are starting little late, I wanted to know till what time we can continue. It's 2:40 now.
So we have time up to 4 o'clock.
Up to 4 o'clock.
So
Okay.
About,
Yeah.
1.5 hours is what we have planned. So 10 minutes we are running late.
Okay, fine. Okay. So what I would suggest now is we will have presentation followed by questions. Okay. I give you 15 minutes and then 5 to 10 minutes for questions. So yes, yeah. So we will start with.
My presentation.
Yeah, sure. So we'll start with M.G. Narasimhan, who will be talking on Jnana Ashwatha is his topic.
Yeah. So, namaste. Good afternoon, everybody. Since this is not first time, I'll just straight away start with the presentation. So, Jnana Ashwatha was visualized by Dr. Lakshmi Tatachar about 5-6 years ago. And so this is about this shloka called Urdhamula Adashakam Ashwatam Prahuravya, which is there in the chapter 15 of the Bhagavad Gita. And it is, can you see? It's coming now. So, yeah. That means it's more than knowledge, of course, but knowledge per se is supposed to be, as per Lord Krishna, it's supposed to be root at the top and then branches in the growing out towards the bottom. So that is what it is, an inverted tree. And so we took this concept of an inverted tree of knowledge with a root at the top and then growing various branches. And this is how the Indian knowledge system is supposed to be organized in our ancient days. So we took that and we made a model of it, and we started doing this project. So the vision is like this. India has a very long knowledge tradition, and we have so many philosophies like Dvaita, Advaita, Vishishtadvaita, Bauddha, Jaina, and so on. All of them have a starting point as to what is knowledge. And knowledge starts with something called Jijnasa, which is the desire to know. So since we have such a long knowledge tradition, we have great respect for knowledge, and then we actually idolize it as Goddess Saraswati and so on. We thought we will leverage this knowledge tradition and try to provide what is called a 360-degree view of knowledge. So if you think about internet, Wikipedia, or any academic, what's called academia.org and so on, you will see that knowledge is in text form. Most people are consuming it today in text form. However, in India, knowledge was also considered to be transmitted orally. It could be transmitted through stories, and it could be transmitted to, for example, dance drama, upanyasas, and things like that. So we wanted to capture all those things and call it a 360-degree view of knowledge. And this is the project, the Jnana Ashwatha, the giant knowledge people tree. So I won't go through all these other things called what's called epistemology and things like that, which is a rather technical thing. So what we want is lots of classification, indexing, categorization, a system to do those things very transparently. So take an example like many people would know this Nalayara Divya Prabandham, which has several explanations. There is a 6,000 Padi explanation, there is a 9,000 Padi explanation, and there is a 64,000 Padi explanation. And there is something called Tamburan Padi for Ariyar Sevai, which is a dance drama form. So all these things are coming from some core knowledge system. And that core knowledge system could be text, it could be oral tradition and so on. So we wanted to have all these things in something called a giant knowledge tree. So these are all again technical things. I don't want to spend too much time on it, but I want to say that this is not Gutenberg, which is a collection of text. It is not Wikipedia, which is about a topic of some depth, and it is not a media content holder. It has all these things, but it is more than that. So what we want is visualize it this way with this kind of work sample there. So there is a what's called Pravaram, which is the Omkara, and the Agamas and the Vedas and the Dravida Vedas. It's some kind of a thing. But now the visualization has changed, and I'll start to show you the demo of that. So here we have, so knowledge also has three things: the knower, the known, and the knowing process. The knowledge itself. Now, knowledge per se is, we call it a subject. The body of work around that knowledge, we will call it a work or pramana. And the author of that knowledge, like Vedavyasa or Valmiki or whatever, we call them pramatas. So these are the Sanskrit terms for subject, work, and author. So with prameya, we start with Omkara, and under Omkara we have something called orthodox heads, secular heads, others and miscellaneous. So under orthodox heads, we get Shruti, Smritis, Dharmashastras, Itihasas, Puranas, Agamas, Darshanas, and Kalas. And again, if you go to Shruti, you will get Vedas, Upavedas, Vedangas. Go to Vedas, you will get the oral tradition, the chronology, the four Vedas. And if you go under the four Vedas, you will get Rigveda, Yajurveda, Samaveda, Atharvaveda. If you take Rigveda, you can see how it is expanding, branches and leaves, and so on. So here we have, for example, the shakas of Rigveda, and you have, for example, the texts, the audios, and
I think your slides are not moving.
Oh, it's not coming at all here? Sorry. I was thinking that I shifted the screen here, but not coming. Can somebody help me on this? It's supposed to show the demo, actually. I thought when I shifted the screen, it would shift there also. It hasn't shifted at all.
If you share the complete platform instead of just one screen.
Yeah, that's it. Okay, now if I shift it.
Yeah.
All right. I'll start from the beginning again. So we have something called the Omkara, which is the root of all knowledge, which is what Lord Krishna calls the root of all the knowledge, is the Omkara Pranava. And in the Omkara Pranava, we classify it as orthodox heads, secular heads. Others, these are all what was later on curated by Dr. Lakshmi Dadachar and his team. So he put it under orthodox heads, secular heads, and so on. Under orthodox heads, we have something called Shruti, Smriti, Smriti, Dharmashastras, Itihasas, Puranas, Agamas, Darshana, and Kala. So if you look at Shruti, you have Vedas, Upavedas, and Vedangas. And under Vedas, you have the oral tradition, the chronology, and the four Vedas, and ancient learning, and so on. Under the four Vedas, you get Rig Veda, Yajurveda, Samaveda, and Atharveda. So if you take Rig Veda, you will see the shakhas of Rig Veda, the karma kandas. I won't go too much into this. It's again more and more of the same, expanding. There are texts, there are audios, and there are videos. If you go to the audios, you will get Rig Veda introduction, which is an audio clip. So if I play that, you will get the introduction to Rig Veda. So it's a long one, so I'll only play it for about 2-3 minutes. I hope you can hear it. Can you hear it? I can't hear it. I can't hear anything. So again, a problem of audio here. But there is an audio clip here, and I have put all this on the cloud also, so I'll share the URL for this later. But I'm not able to hear anything here. So I'm sorry, but actually clips are there. We should be able to play it. This is which was the more attractive part of the system, which I'm not able to show you now. So again, there are many. Each section has its own audios. Like I have Rig Veda audio 1, audio 2, and so on. It's playing, but you're not here. Okay, now you're hearing it. Now I think
गणानां गणपतिं हवामहे कविं कवीनामुपमश्रवस्तमम्
so I'll not play it.
ज्येष्ठराजं
I'll just show you the later on. I'll share the URL where you can all go to this. So same way I have, for example, for Yajurveda, but that's not properly. My Yajurveda is actually it's playing Vishnu Sahasranam, which is not in the correct place. But apart from audios, I can also show you videos. I mean, videos are there, but this is the YouTube link, which I don't have Wi-Fi here, so I'll not be able to play it. So, but videos are also there for chanting and science in Rig Veda and so on. So if I go to the chanting, it will show that, but it will not be able to play because it can't find the YouTube site because its internet is not there. So similarly, if I go to Pramana, this is all what's called subject. That is the Vidya itself, the subjects under Omkara and Vedas and so on. Pramana is the body of evidence. That is, if you say Sri Bhashyam is a Pramana which takes its basis as the Vedas and the Upanishads, and they have made their own. Sri Ramanujaya has written or constructed this particular work called Sri Bhashyam, which is a proof or a body of evidence based on the subject of Vedas and Upanishads and so on. So under works, if I go to the Vedas and I go to what's called Ubhaya Vedanta, Dravida Vedas, again under that I have Tiruvaimali. Tiruvaimali is a well-known with Pasharams and so on. So if you take Tiruvaimali and in Tamil, so I have the first centum, the first decade, and the first verse, and the original text and the Vyakhyanams, Tippani, Ityadi, lexicons. If I take the original text, musical rendering,
உயர்வர உயர்நலம்
உடையவன் யவனவன் மயர்வரமதிநலம் மருளினன் யவனவன் அயர்வரும் அமரர்கள் அதிபதியவனவன் துயரறு சுடரடி தொழுதழன் மனனே.
Then I have what's called a recital, which is one by Dr. Lakshmi Tatachar himself here.
உயர்வர உயர்நலம் உடையவன் யவனவன் மயர்வர மதிநலம் அருளினன் யவனவன் அயர்வரும் அமரர்கள் அதிபதி யவனவன் துயரர் சுடரடி தொழுதழன் மனனே.
And a chorus, a goshti.
உயர்வர உயர்நலம் உடையவன் யவனவன் மயர்வர மதிநலம் அருளினன் யவனவன் அயர்வரும் அமரர்கள் அதிபதி யவனவன் துயரர் சுடரடி தொழுதழன் மனனே.
So, to just show a little more in depth, this has again been analyzed as a written text, as a prose order, word splitting, and so on. If I go to what's called word to word meaning, there's a word to word meaning also.
உயர்வு அற தன்னை பார்க்கிலும் உயர்த்தி இல்லாதபடி உயர் உயர்ந்த நலம் ஆனந்தம் முதலிய கல்யாண குணங்களை உடையவன் சுயமாக உடையனானவன் யவன் அவன் யாவனொருவனோ மயர்வு அற அஞ்ஞானம் நசிக்கும்படி மதிநலம் ஞானத்தையும் பக்தியையும் அருளினன் அடியேனுக்கு கிருபை பண்ணினவன் யவனவன் யாவனொருவனோ அயர்வு அரும் மறப்பு இல்லாத அமரர்கள் நித்தியசூரிகளுக்கு அதிபதி யவன் சுவாமி யாவனொருவனோ அவன் அந்த எம்பெருமானது துயர் அறு சுடரடி துயர் அறப் பெற்ற சோதிமயமான திருவடிகளை தொழுது வணங்கி எழு நீ கடைத்தேறக் கடவை என் மனனே எனது மனமே.
Complete
So five
word
more
meaning and a purport and prosody and special information. Everything is in depth. It was, I mean, here it is not there, but it has been organized in such a way that people can go in depth into one little topic into that vast ocean of knowledge that is there, and then they can. It is a kind of a spiritual journey. This is what I wanted to show as how wonderfully organized one can have when you have an Indian knowledge system and a tree view of things. So any other questions, I'll take it later. But
so any questions? Yes, Professor M.D. Srinivas. Can you pass the mic?
Madhusudana Saraswati had a work called Prasthana Beda, I think, where he tried to sort out all existing knowledge in some manner. I don't know whether you have seen.
I haven't heard of it. It could be the inspiration for the work that Dr. Lakshmi does. He visualized it this way. So it could be the inspiration for that. And this is a very great work because curation is very important. What to place where and how to organize it in such a way that it becomes easy. How to get the antecedents of a particular subject or a work. Everything is possible with this kind of a framework. This is what I wanted.
Is it available for the public? Is this available for the public?
Yes.
Okay.
I'll put it on the cloud. I'll say share the website address.
Yeah. Can we structure this database in a syntactic way or some sort of a semantic network way where everybody could use? Today what is happening is there are pockets of development, I'm saying, each one trying to develop their own databases, structure them in their own way.
Our vision is that it should be collectively done.
Yes.
A collection of scholars should come and together and start gathering this kind of scholarly, it is not at all data, it is scholarly knowledge.
Absolutely.
Put it together properly.
Yeah.
And then place it properly in it. Another little thing I wanted to show you is you can see that each of these links has colors. Each of these colors is actually a relationship. For example, this particular thing is called a part-whole relationship.
It's not visible here. Sorry.
Again, you can't. Oh, you have switched it on. You switched it on.
Yeah.
Okay, when you see it on the cloud, you'll be able to see various things, and then you can always contact me and for
Yeah, but can we perhaps make it a little public open to the people to get to know? Don't do the local developments. Here is one database which will have the Dvaita, Advaita, Vishishta, Advaita, all encompassing, structured in a way, in a system, in a semantic way actually. Just the dictionary will not help us actually in terms of NLP.
So use mic. Please use mic.
It is an open source project. I have put it on the cloud. It is also available. The source code is available. The data is available. Everything is available openly for people to enhance and get benefit of and join in as volunteers. It's all open. Yeah. So that is what I wanted.
So thank you very much, Narasimhanji. I just wanted to make one comment on the work. I remember having discussions with Professor Lakshmikant Tatacharyaji when he visited Hyderabad, and he was talking about the same Ashwatha. And essentially, here what is done is just a part of it. He has a huge, very grand vision, and whatever is implemented is just a starting point of it. Still, many other things are to be done. What he had in mind was there are various kinds of sangatis in our Shastra. There is Shastra Sangati, Adhikarana Sangati, Adhyaya Sangati, and all that. What it is done here is just the Shastra Sangati, how the various Shastras or texts are related, and he is then further going into Adhyaya, Pada, etc. So that kind of structure is built now. But further, much more. Yeah, yes, so that needs to be done. What you have said is well taken, and he said that he is making it available on GitHub-like platform so that others can take from it and then add to it. Yes. So thank you very much, Narasimhanji, for excellent demonstration. Yes. Yeah. And now I invite the second speaker, Dr. Venkat Subramaniam from Vyoma Linguistics.
गुरुरेव गतिः गुरुमेव भजे गुरुणैव सहास्मि नमो गुरवे न गुरोः परमं शिशुरस्मि गुरोः मतिरस्ति गुरौ मम पाहि गुरो हयग्रीव हयग्रीव हयग्रीवेति यो वदेत् तस्य निस्सरते वाणी जह्नुकन्या प्रवाहवत् असाध्य साधक स्वामिन् असाध्यं तव किं वद रामदूत दया सिन्धो मत्कार्यं साधय प्रभो अथाति विद्यम् आचार्यः पूर्वरूपम् अन्ते वास्युत्तररूपं विद्या सन्धिः प्रवचनगुं सन्धानम् इत्यधि विद्यम् नमस्सभाभ्यः सभापतिभ्यश्च. Today I will be talking on a very favorite topic for everybody, 360-degree approach to the learner experience in e-learning for Sanskrit. So before I start, I would like to thank people who have contributed at the thought leadership level, at the working level. Dr. Srinivasa Varakedi, who has been my mentor in this area. Sudhir Patavardhan, who is the CTO of Vyoma Labs. Vishwanathan, who is the CEO of my labs. And my sincere namaskarams to Professor Lakshmi Tatachar, who actually sowed the seed into our minds in starting this kind of an e-learning initiative. There are 3 parts to this presentation. First, we will be talking about the challenges in e-learning. Then we will be talking about some solutions that have been implemented across various organizations. We have also implemented some of the things. And then we will be talking about 2 important things, which is a collaborative learning, and the next which we are going to talk about 360-degree learning. So when we see the challenges in e-learning, all of us, how many of us have used e-learning for learning something here? Everybody here has used e-learning. So that means we know most of these challenges which I am going to indicate. Some of these 10 years ago, they were basic challenges. Then we have some teacher related challenges, we have some technology related challenges. From a learner perspective, I was remembering Karnataka Sanskrit University. One day I went to I was speaking to my guru, Soti Nagaraj, who taught me Vyakarana Shastra. He was telling, he was talking about this one, the number of students coming into the university, Sanskrit universities and other things. So if you go and ask the teacher, he will say, when I come and teach, the student is not there. When student is there, teacher is not there. So this was an Anyonya Ashraya dosha, which was there 10 years ago. Now today, all these kind of things are totally removed by e-learning coming into the platforms. So many organizations, Sanskrit Promotion Foundation, Samskrita Bharati, Samsadhani, so many organizations have started their own tools, e-learning, etc., which paves the way for learning. So you have content all over the place, you can always learn if you have the desire to learn. Location problems. Guru, the Shastra Guru is in some other place, you are in some other place, today I cannot learn. Now those kind of problems 15 years ago it existed, it's not there. Time conflicts, all these things, it was, before it was existing, now it is not there. So from the learner side, the next level challenges is you have started learning, now you are embarking on a journey, learning journey. There you have to classify yourselves into a persona. Am I a kid of, though the personas when we talk of personas, kids, children persona, then you have school children, high school children, then you have college and university students, you have professionals, homemakers, you have senior citizens, you have the special children. Different personas are there. Which persona I belong to? What is my learning style? Auditory, visual, kinesthetic. Each person has got his own learning style based on which he gets maximum out of the learning. He has to find out what it is. And if that learning type is given by the teacher, he picks it up. Shigroupastitihi bhavati. Objective. What is the objective? You have so many objectives. People learn Sanskritam, Shastra, they have so many objectives. Some people say, I want to do Sambhashana Sanskritam. Some people say, I want to do Shankara Bhashyam, Vedanta, pronunciation, Kavyas, understanding of Kavyas. Some people say, Sanskrit gives memory, focus, concentration. I want to improve my memory, focus, concentration. Is there a course like that which can improve my memory course? So there are different objectives and there is a proficiency. Every person is proficient at a particular level. He may be a beginner, he may be so I may have advanced learning in Vyakarana, but I may be a beginner in Vedanta. So that way proficiency, basic, intermediate, advanced, time availability for learning, authentic content. Is the content that I am learning authentic from whichever source I am taking? Should I do any unlearning later? This is a very important thing. Progress tracking. If I am learning, in my traditional Guru Sishya Sambandha, my Guru is going to tell, you have learned this much, there is a pariksha, he is going to assess my learning, he is going to correct my mistakes. Is that kind of thing possible? Certification, of course, for the Lokamanyata. And some learning joy experience. Am I getting that joy? Am I actually learning? These are the learner challenges in e-learning. On the teacher side, You have these things were basic things which has now been eradicated. Then the teaching from the journey side of the teacher, he is looking at how do I develop an online content which is more engaging and which can suit the learning style of different learners. If he is a college student, he has to be given in a different way. If he is a senior citizen, he has to be given, the content has to be presented in a different way. All those things. And if I have some webinar tools, today we are using a lot of webinar tools, Zoom, all these platforms we are using, GoToWebinar. Can I integrate this with my thing, with my LMS, learning management system? Suppose I come up with a learning management system. See, in America, most of the universities, they use Canvas, which is a learning management system. Earlier, the learning management system, basic learning management system that was prevalent was Moodle. It was basically a content-based system which was there. Now today, learners are asking now. Today in India universities, you have the Government of India platforms, Swayam MOOC-based platforms. I have seen KKS University using an LMS system. I have seen Central Sanskrit University recently launching many courses through an LMS. They are launching a lot of things. So how are we storing this? How is it engaging different persona, different learner styles? And finally, the most important thing is the learning happening and first class to last class retention. This is one of the greatest thing that we measure. What is the learner retention? First class, this was e-learning class. Everybody came to the first class. Did they continue the learning? Learner retention rate, very important thing. Then you have some technology challenges, user management, content creation. User management, different roles. You need an administrator for an LMS. You need a teacher-based login for him, different types of access. All those things, role-based access. Content creation within the tool, within the LMS. Integration of different tools, storing, streaming high definition videos. Sometimes, many times, streaming does not happen. The LMS works well, but when it comes to streaming of high videos, there is a failure. Collaborative, how collaborative it is, what is the assessment? Is there a recommendation from an artificial intelligence based recommendation, wherein I get, okay, this I have finished, the next thing you have to do is this. Is there something, a recommendation like that? These are some technology challenges. The other things, when we are as organization, we need lot of analytics and reports, student life cycle report, course life cycle, multi-course, portal activity, lot of things we need, teacher reports, how did the teacher perform, how many classes he or she took, user management reports, security reports, sales report, if there is it's a paid course, what is the finance report. Then if you want to put Google Analytics, etc. on top of that, how all these things are dashboards and analytics. And moreover, sometimes you may need dynamic reports. See, if on this day, what happened to this course? So you need to have something like Power BI, like a Microsoft tool or something where dynamic reports, the user can customize these reports and dynamically see the changes in the visualization. These kind of reports also are required. Multimodal framework for the learner. In the technology, today I started learning something and I had to catch my metro train. I came to the metro, I have a mobile. Can I continue the learning in my metro train? Then I reached the office. I have 15 minutes before. Can I learn now? Or I reached home. So multimodal framework, same content accessible across different platforms. Then which is continued learning on the go and learning recommendations. So what we have done is we have implemented some of these solutions. We took a LMS from the market, which is a robust product done by a service provider, and then on top of it, we did a POPT model, persona objective proficiency time model, and this is an automated, through which an automated learning path is generated for the learner. Suppose he doesn't know what he has to do, which course he has to take, how he has to learn. This is what it gives. So persona objective proficiency. So personas I have already told 30, and objectives also. For every persona we have identified about 30. We did a survey wherein we spoke to all these end users. We have about 30 objectives that. So If you go to a university student, he will first say, I want to get more marks in my Vyakarana exam. I want to pass the UGC NET exam. Tell me what is there in your thing for that. So they have different objectives. A person who is a musician, he will say, when I sing my song, Dikshitar's song, I should have tears and I should understand the bhava. When I read a Parayana, guy says, when I do Parayana of Valmiki Ramayana, I should be able to understand the Ramayana Vakyas. That is how I should, these are my objectives of learning. So they have different objectives. These objectives we have mapped into it. And then we give a questionnaire once he clicks on that. And to determine whether he is a basic learner or an intermediate learner or an advanced learner. And his time availability. Based on his time availability, we suggest a customized learning path for him. And it is there in the learning page. Earlier what we used to do is, I used to call everybody to our house or our office and say, what is that you want to do? This child will say, I want to do Shankara Bhashya, means I will give him in one paper, I will write everything and give and say, this is the path for Shankara Bhashya. Then he will say, okay. And he will say, okay, so many years it will take, all those things he will understand. But today it's an automatic generator. And today we are thinking of, even once that learning path comes into your learning dashboard, after that you can bring it to your calendar, Outlook or Google Calendar. Based on your time availability, it will calendarize it for you. That also can happen. So this is the screenshot of a sample learning path generator. The first step is persona, objective, assessment, time, learning path. These are the questions which will come. Then you will have the questions. When you answer this is the learning path which is generated for the objective that was given and the time availability that was given. This is the first solution that we have implemented. Now, is this solution randomly done, or is there as a basis for it? The basis for it is the traditional Shastrajñas who follow, what is the model they follow for Sanskrit learning. They follow the Bhashadhyanam first and then go for Granthaadhyanam. Take a particular Grantha. In Bhashadhyanam, you learn the basics of the language, LSRW skills plus some basics of grammar. In Granthaadhyanam, you take a particular text, Shatashlokena Panditaha, Niti Shatakam, Sankshepa Ramayanam, Shishupala Vadham, whatever you take, you can take the entire text and you can learn in detail so that you can understand. In 100 shlokas, you can probably understand all aspects of that shloka. Then you have Shastradhyanam. Depending on your interest, you can go there. And applied Sanskritam, which is Vinyoga Samskritam, which is IKS and other things. Today we have ancient Indian mathematics, all these things, IKS areas. There are about 30 areas identified by Ministry of Education. So all that also comes in applied Vinyoga Samskritam. So now when you base this entire model on this entire learning path on this model, and we have made sure that this model is followed, and this we have implemented in the LMS. So this learner journey related problems, most of it is eradicated by this. The next solution that we have come to is the integration of tools. Today, we earlier based on advice of Professor Lakshmi Tatachar, we started initially as a self-learning tools developing company. We used to develop tools for Sanskritam learning. We developed a tool for Sanskrit, Bala Modini, Sandhi, Samasa, etc. So those tools that we developed in HTML5, in Adobe Articulate, all those things had to come inside the LMS, and it has to be modularized. So it was initially a big tool, but it has to be given in bite size for the learner to take it. So that was one integration that we solved. Then this is an Adobe Articulate authoring tool, interactive multimedia. So inside the LMS, there is a frame. This is the LMS. This part is the LMS. This is the tool, Adobe Articulate tool. Here you have the buttons inside the tool through which you can interact inside the tool. You can play games. You can do whatever you want inside the tool. So the game development happened separately. The LMS was different. That entire thing came and sat here. So we solved one problem there. Then games and activities. This is about Sandhi tool. Text, you have text, audio, charts, animation, games, etc. Then there was one more tool which we developed with the help of IIT Kanpur, Professor Arnab Bhattacharya and Shikesh Terdarkal. They helped us in taking an open source code and did an audio alignment. We had an audio tool of Ashtadhyayi, one of our scholars and we all did an audio recording of Ashtadhyayi, which is in Parayanam mode and student repetition mode. So that was audio alignment was done for that text inside the, and a text was placed, and you have a loop and a speed control, just like you have, there is one tool called Audipo, you saw software if you download, or even in VLC player you have the speed control. So that thing we did inside this, so that the learner can easily memorize the text. If he has 20 sutras, he will mark first sutra as A, second, third, 20th sutra as B, A to B, it will keep on repeating. So that is looping, speed control, text hovering. Then the next, these solved some of the teacher and learner engagement. Then webinar integration. See, you have so many webinars, you are attending so many courses, you do, one is through Zoom, one is through webinar, one is through this one. How do I integrate this? All this into our LMS portal. You need not remember the password, etc., automatic reminders, recordings, content storing in drives. All these things are happening. Then the computer-based international assessment standards. So because we have taken this PMP exam, so in PMP international exams, you have this kind of a dashboard where student knows what is the question and how much he has answered. These are the questions, answered, not answered, etc., marked for review. He didn't know the answer, he will mark for review, or he will say I will come back. Then he will go back and finish the assessment and come back. So this is something. Then this entire summary is displayed where it says, do you want to submit this? So this kind of initially the tool did not have all these things. We brought this inside that, and an automated certificate, which is now very common. Everywhere you go, you get this. Now coming to the center of the next part of the presentation, which is the third part, which is collaborative e-learning. So what is that we are, but when we talk to a learner, we say, are you satisfied with all that we have given? He says, no sir, I want more, I want this. Do you have something like this which Ambaji has developed in Samsadhani? Do you have something like this which Sanskrit Promotion Foundation has done? Do you have this video? Do you have this tool? Like that they keep on asking. So bringing all relevant online content on demand to the learner. So let us take a case study. Tapaswadhyaya niratam tapasvi vagvidambaram Naradam Paripapracha Valmikir Munipungavam Ramayana Shloka Prathama Shloka. I just put there. You need to know the Moolam of very well. You need, for Moolam, you need to know the pronunciation audio. You need to know the basic meaning. You need to know the Padacheda, Anvaya, Vyakarana aspects, Pada Parichaya, Subanta, Tiganta, etc., Samasa, Saddhi, Parichaya, everything. And if you are an advanced learner, you go to the commentaries and see what is Tapaha, why it started with Takara, all those things. You will keep on seeing the commentaries, Tilaka, Bhushana, etc. You have IIT Kanpur website giving commentaries, etc. in the tool. Then if students are there, we need to give quiz games, we can engage them. Sometimes there are upanyasas that we hear, Chaganti from Andhra, or somebody, Krishna Premi Anna from Tamil Nadu, somebody, different people, they have upanyasas which they talk. So we want to link all those things. Discussions, we want to discuss with our peers. Shastric aspects of a particular thing. Dharma Shastra related, Dharma Kutam is a Vyakyana of Ramayana. If you go to Dharma Kutam, it will show you what is the Dharma Shastra aspect in Balakanda and which sloka is connected to that. So Vinyoga, and how you can use these kind of principles, Ayodhya Kanda, Kaschit Sarga, can you use it for governance of this country? Same way you have other things like Aditya Hridayam, 3 level meanings, some of the Vedantic aspects are there. So like this leadership lessons from Sundarakanda, all these kind of things we can do. And then finally an assessment of our own learning at every stage or different stages. So this is there now. If you do this, if you go to the internet, for the learner, these are the things which are present in the internet. So he has a Sanskrit world which gives Moola, he has a Sanskrit documents, he has Samsadhani, which is University of Hyderabad, which gives Padacheda, Karaka analysis, morphological analysis, everything he gives. You have a Kosha.Sanskrit today, you don't know the meaning of a word, you want Amara Kosha thing from there, or you can use different tools. Every organization has developed different tools. You can learn from the Praveshika, this one. If you want to learn grammar aspects, you can come to Sanskrit from Home, Vyoma site. You can learn from Ambaji's site. You can learn from Sanskrit Promotion Foundation. After that, you can once you learn, you have the basic text. You have IIT Kanpur website here. This is the IIT Kanpur website. I think most of you have used it, Geeta Super Site. Then you have OCR. So if you have a text, you want to do OCR and then start using it for research, etc. from the GitHub, etc. You want PDFs, you can use from archive. All these things. And then if you want to use social media to discuss about it. No, all these things a learner is today faced with. He wants a collaborative platform. He is telling, can on-demand collaboration. I need this at this point. In your LMS, is this there? Is this coming? Is the tool of Kosha.Sanskrit today? Can I use it inside your LMS? Can I use it, Ambaji's tools inside the LMS? This is what the learner's demand. So the ultimate joy is, this is what we call, from the collaborative learning, we need to go to the next step called 360-degree learning. Where textual ebooks, flipbooks, audio, presentations are available at one side, tables, diagrams, charts. Nyaya Shastra, the Vidyadhari Vyakhyana is full of charts. So those charts needs to come into this. Interactive multimedia simulations. You need to simulate and you need to show this. This is how this Sandhi is happening with a case study. You need to have AI-based recommendation. What is the next best thing? Suppose you make a mistake when you are learning. The next thing that the tool should say is, why don't you go and learn Sandhi, Anunasika Sandhi or Sattva Sandhi or whatever Sandhi and come back here. Why don't you go to ashtadhyayi.com, see the sutra, see the meaning, go there. Why don't you visit Samsadhani and come back? So these are the recommendations which the tool has to do. This is not something which we have done. These 2 slides are something which we have to do as a team, as a technological team, as a set of team members here. And personalized projects for a learner, finally he has to learn what he is a learner. He is focused on learning. He has to be given assignments, activities. He has to be given a chance to present himself. He has to do a Vakyartha Sabha. If you listen, we remember doing a Vagvardhini Sabha in a Prayodamanorama class. So the people felt very happy when they did that presentation of Shastra Vakyartha. So research articles, presentation of research articles, then this collaborative online and offline resources, group discussions, the discussion forums which I have seen in some of the IIMs and etc. in the LMS of the universities, the discussion forum is very powerful. The moment one student raises a doubt, the answer is there and everybody gets the answer. So the next student will not raise the same doubt. So it is clarified. So and it is stored. And if it is a very important question related to the subject, it is stored there and it is available for archival and retrieval. The next one is how to engage the learner, the cinematized learning, then giving a confidence-based assessment. Today we are measuring, doing some assessment and telling you have this much marks. What is the confidence you have on the subject? Can we measure this confidence of the student? That is something we are looking at. Learning on the go, which we discussed, progress tracking, assessment, and continuous critical feedback, which is what a guru would have given you. Can we give that in this 360-degree Sanskrit learning? So finally, this is a summary, last slide. So we are moving from a traditional, say Moodle, which I mentioned, was a traditional 15 years ago, it was or 20 years ago, it was just a static storage recording kind of a LMS where you just have some basic things. It was more of teacher centric. Teacher wanted to put something on the web, so he used this. That was more teacher centric. The next thing that we are going is the learner centric model, where we are a learner experience system, where you have the learning path which we showed, POPT model, persona based discussion forums, game based learning, progressive graded assessment. So you have the graded assessments. It should be progressive. First assessment should be easy, next one should be intermediate, next should be difficult. That is how the guru used to ask us in Shastras. Learning, and the third kind of this is more than an LMS, learning management system. We can call it a learner experience system, LXP or something. We can name it that way. Learning centric. Learning centric is more of collaborating. The learner wants this on demand, he is asking. So there, and then which is AI based, and then get into the AI plus based, where we say it's a 360-degree learning, where collaborative technology is there, on demand content, progress tracking, personal recommendations based on the actions of the learner, confidence-based assessment, mentoring by advanced learners. Suppose you have a classroom and in that you have an advanced learner. He is learning that for such a long time. Why don't you get mentored by him? Can that be possible? And gaming, today we are having games to learn some things. From gaming, can we move to a cinematized learning? Because if you see a movie, everybody is attracted to a movie, and by the time they finish the movie, they can talk anything inside the movie. But they will not remember the Gita Shloka or Gita Vyakhyana, but they will remember the dialogue inside the movie. This is Kali Yuga, so we can't help it. But we can proceed to cinematized learning and see how we can do this. Cross-organizational leadership, where organizations like the Computational Linguistic Forum, Ambaji has got a forum, Sanskrit Computational Linguistic Forum, JNU, Ambaji, Gerard Huet, all these, they have a lot of content. Can all these content-based people come together and collaborate so that we can give a very good experience to the 360-degree experience to the learner. So at the end, we close it with the same Upanishad thing. Actually, this thought was given by Professor Srinivasa Arkedi. So in one of the conferences, when I was doing my PhD in his this one, he called me to one of his class. So in one of the classes, he asked, so should the entire learning be teacher-centric or learner-centric? So everybody answered learner-centric, learner-centric. Then he said, see the Upanishad Vakya, Acharya Purva Rupam, Anteva Sukta Rupam, Vidya Sandhi. So it has to be learning-centric, and we have to move towards that. The learning has to happen finally, and that is what was the message given by our Acharya. And with that, the presentation is, this is one thing that we all together have to do. If you have any questions on these things, you can ask. Whatever to the extent possible, I will answer. I have Vishwanathan with me, who has contributed for this presentation. He can also answer some of the questions. Sir. Yes, sir.
Can you hear me now? Yeah. Vidya has to be central, and if you look at achievement surveys, there are gaps versus learning outcomes, even for foundational literacy. So it's there in various languages, English, Hindi, and so on. Sanskrit also will have those gaps as well. So if you tie up with someone, some body that is accountable, responsible for controlling those learning outcomes, then this can translate to mass level learning achievement. Otherwise, only a smaller section will stand to benefit.
I didn't understand, sir. That.
So most children are not able to read. Most children are not able to read
Okay.
fluently.
Okay.
Like 60 words per minute, class 3, with comprehension and so on. In various languages, English, Hindi. I'm sure that the same thing would be there for Sanskrit as well. So maybe your organization is not the one dealing with that problem. But unless you tie up with some body that is accountable, responsible for that, and maybe it's not government, I don't know who it is. Aspirations are there, but there are gaps on ground.
Okay.
So if you tie up with that, then everybody larger mass gains. Otherwise, it's a small section that is going to benefit from this.
Thank you very much for your suggestion, sir. Thank you.
Sir, can learning of Veda Patanam, especially Yajurveda Mantra, because which have got the involvement of Anudatta, Udatta, application of Abhyantara Praitnaha, Bahya Praitnaha, of a traditional system of Guru Sishya, Guru Muktaha, be successfully replaced by the e-learning system? Is it possible?
We can't say it is not possible. It is definitely possible, provided the Guru takes 2-3 steps further. Sishya also takes 2-3 steps further. And it is possible. But initially, from a traditional Vedic perspective, initially Vishwanath will answer that. Initially, probably in Kannada they say, Swara kutko beku. First the Swara has to sit in your vocabulary. The Vedic Swara, see, today you can by heart one Gananantva and tell it off. But if you have to tell the full Samhita in a continuous way, that Swarasthana should sit. For the Swarasthana to sit, there has to be a training under a Guru. And when it sits, probably you can you can start learning. After the Swarasthana has sat and Guru is convinced that you can do the Tiruvai and Sandhai or whatever you're supposed to, then probably it can be made successful. It cannot be only online learning, in my opinion. It can be a blended learning. Many people are learning Vedas like that. They first go to a teacher, learn 6 months, they will do that. After that, that one-on-one thing through online is being done through phone or informal methods, phone, WhatsApp, etc.
Okay, thank you, sir.
Any other questions? Comments?
Namaskaram. Do you have any special series for children with disorders, like specially able children, like autism and all, or speech disorders?
I would request Vishwanathan to take that answer. He is working on that.
Yeah. So we do have some basic which are based on the textual therapy, chanting therapy, visual counting, and those kind of things are being worked on actually. And we do have a colleague who is also getting the benefit, and through which who is also he's there along with us for around 5-6 years now. Karthik, he's not come today, but he's getting the benefit of these kind of experiments. So which we want to take it along, like you said, with the help of some organization who are all better trained in these kind of handling it, because we have the content for it, the methodology, the do's, don'ts, how we should approach it. We are planning to collaborate with somebody and take it, because that is in one of the 7 persona we have identified special.
We have identified that as a special person.
Yeah. Yes, speech therapies.
They do a normal.
Through the chanting, yes, through the chanting of shlokas. It is very successful.
Concentration and the speech.
Absolutely.
That will be beneficial.
Yes, we are working on it. Thank you.
So, thank you very much.
I would like to ask one question. Whether it is possible to illustrate these things instead of E. Panchatantra was there. The children of the Raja was taught in a way, they got it. Is it better than e-learning, or is comparable to e-learning? That's what I'm asking. Can you repeat that? Instead of e-learning, Panchatantra way might be more easier for people to learn. Isn't it?
Sure. So in the last slide, if he can just go back, one of the components of e-learning is a story-based, cinematized, emotional-based learning. That is one of the component, along with other components. Because some people are good for textual, some are for auditory, some people want to do projects kinesthetic. So depending on that, it changes. Depending on the persona, depending on the style. One size doesn't fit, one size fits one only actually.
What I'm asking you is, yes, you have to go to the website and everything for this. Is it possible to publish, just like Panchatantra, there are so many books and all that. Is it possible to do that? That's what I'm asking. So that average, below average people like me can learn that.
We can publish books actually, but from an e-learning, it will be a different thing. Sure, sir. Sure, sir. We can publish that also. We'll think about it. Thank you.
So, thank you very much, Venkat. It was a very nice presentation, which also evoked so many questions. I have seen in the last 15-20 years, I have been watching you for the last 15 years. You have gone a long way, and you have taken advantage of the lessons from Corona and moved to this e-learning full-fledgedly with various aspects. So thank you very much for the presentation. Next, I invite Adish. Anish Srivallabh Chivakulla, and he will be talking on applied data analytics and computational Sanskrit. So you have 25 minutes for presentation.
You want to use this mic or column mic? I can use this. Okay. It's not moving. Once. This is on. Forward. Back. Okay. Once. Yeah.
Good afternoon, everyone. I have a lot of content here. The idea is to give you a breadth view of the latest developments and set the context for further research. I present several research problems, so depending on time, I'll cover as much as I can. And I'm not sure if the pictures are visible, so I'll go there and try to explain. So the topic is data analytics for Sanskrit and Indian language NLP. So we have to first understand what is data analytics and the latest developments in it. So here on the top left, I show a diagram where all the different subjects which deal with data analytics are given. So we have things like statistics coming from mathematics. Then we have machine learning about algorithms design. And we have databases from systems. So we want to combine all these techniques into what we call data analytics. And on the right side, top and bottom, I have a process of arranging a project which has data analytics, where there are different steps one can go through, starting with data collection, understanding the application, building models, deploying them in a real environment, evaluating them. One point to note is the project management here is an iterative incremental process. So you are never done with it. You only decide to stop after some time, after you're exhausted. And we want to place these projects in the context of traditional project management, such as software engineering. So what's on the bottom left is IEEE standard, which tells you where data analytics fits into a bigger project life cycle. On the top left, I have a diagram for predictive analytics, where there is a notion of an input and an output coming out as a prediction by processing that input. And then there is a box on the right side, which is a further optimization one does in addition to the predictive analytics to get to the task at hand, to get to a solution. And on the top and on the bottom left, I have a diagram on how pattern recognition is done. The box on the left side tells you how to get the variables of interest for building the model. Box on the right side tells you how to build the model. Most of the research is focused on building the models, but most of the practice in the industry, for example, is focused on getting those variables. And we have to have algorithms designed and implemented and deployed for each step. This leads us to bottom right blue diagram, where you start with a descriptive version of the data, just want to explore the data. Then you want to come up with new attributes which are not there in the data, predictive version of analytics. Then there are other types of analytics. We can come up with n number of definitions for analytics. And on the top right, I have a diagram of the components, elements of machine learning system. So what is machine learning and how do you do the inferencing in it? How do you go from raw data to the inferences? How do you use the inferences in the real world setting? I'm not sure if you can see it. I'll try to share the slides. Okay, so this is how we organize the projects and build the models. Now, when we have latest developments like deep learning, we are looking at a diagram like bottom left, where we have to come up with a design of an algorithm having these elements. It's like any normal algorithm, but in additional, we have things like loss function, which we have to define, architecture of the neural network, which we have to define. And these are all design choices we make, depending on which the efficiency and usability of the algorithm and the model and the system is decided. And on the bottom right, I have ways to think about how to come up with these variables or inputs to the algorithm. This takes us into a lot of philosophical issues. So for example, what is inference? What is perception? And how do you prove things? What is a valid source of knowledge? These kind of things. So that was a very quick overview of how to build the model. Now the challenges with building those models is, one of this is this. It's called big data, where you have all these V's. There are 25 V's. Volume, variety, velocity, veracity, etc. And these are all characteristics of the new kinds of data we are able to collect. Such as volume is large scale data is possible. Variety is different sources and different types of data can be collected, and so on. Then I want to talk about computational intelligence, which is one area of artificial intelligence which I feel is useful for modeling Sanskrit-based knowledge, where there are some elements to this computational intelligence. One is it can deal with imprecise, partial truth and reason under uncertainty. And we want to build some kind of AI agent model which is able to have this intelligence. Similarly, it can look at multi-valued logic instead of binary logic. And to be able to actually implement this, the elements are fuzzy logic, where the value of a feature with a linguistic description can be mapped to a fuzzy set. So it's extension of standard set theory, where the boundaries between two sets are fuzzy. There can be overlapping boundaries. And one tries to build rule-based systems based on this fuzzy logic, and a lot of Sanskrit techniques can be incorporated into these rule-based systems. The other element is evolutionary computing, things like genetic algorithms. The idea is to find solution to a function, and we are trying to find through a derivative of the function and arrive at an optimum value empirically to approximate the function value for new inputs, so that we are able to, as much as possible, accurately predict the output. And normally gradient descent is you take the derivative of the function, but if the derivative cannot be found, then you use algorithms like this. They are search algorithms, and then they do further optimization. And they can be deployed on commercial IT systems. You can get commodity hardware like GPUs and scale them out. So here one has to define, just like any optimization problem, an objective function, some constraints, parameters in it, then come up with what is it we are targeting as an optimum solution to that problem. But the search and optimization problem is a bit different, and it matches the fuzzy logic. Okay, then there is decision sciences, decision theory. What is a decision? Normally, how do we make decisions? Through heuristics, but how can we put it into an algorithm? And here I want to emphasize this idea of rationality. So what is a rational and what is a irrational decision? And this idea can be used by us to design agents, AI agents, like chatbots. And you can experiment with a lot of Sanskrit ideas in these bots. So the rationality can be expressed using game theory, for instance. Game theory comes from economics, where there is a market of interactions going on, and there are players causing these interactions, and there is a convergence of these interactions to an optimum solution. So the agent finally is able to do the task which we want it to do, such as answer our question, after it has converged through several interactions. Okay, so that is overview of data analytics. Now, how do we apply these techniques to Sanskrit problems? So there are three different ways right now you can find in the literature on how Sanskrit corpus is analyzed. One is symbolic, rule-based. Another is statistical, probability-based. Another is deep learning. So deep learning is the latest development. So rest of the presentation will be around that. So I give you all the definitions here. And here are the typical tasks, low-level problems which we solve in computational linguistics, specific to Sanskrit. And in general, any Indian language or any foreign language also. So there is language detection, sentence segmentation, word segmentation, language modeling, part of speech tagging, named entity recognition. I give all the definitions here. So I don't have time to go into each one. Just to give you an overview of all the tasks which we want to solve using the algorithms from the application perspective. So there is morphological parsing, dependency parsing, so on and so on. Now we have to select one of these tasks, such as question answering, to design that AI agent, AI model and then think about what sort of deep learning goes into it. So deep learning has been used mostly on English corpus to do things like word embedding, create a search space for all the words in a piece of text, and you can also assign probabilities to each of generating each word in a piece of text, so that how these probabilities link to each other creates a structure for us. That's the model. And this leads us into all these problems like question answering, reading comprehension, word embeddings. These are all these can be experimented by us in that AI model, that black box. And how we do the experiment, what technique we apply, the learning bit. Learning is some pattern is being learnt by the algorithm according to previous frameworks. So that learning bit can be categorized by us into all these different types. You have representation learning. The raw data is going to be processed into something more useful to the model. Dictionary learning, a low dimensional representation of the raw data. Discriminative learning, predictive analytics kind of thing. Sequential learning, probability being assigned to each word, and bunch of probabilities which have already occurred are used to predict new probabilities. Transfer learning, model has learned something from a particular data set. We want to transfer some of its whatever learnings, patterns, higher level representations of data into a separate model or to a separate language. So you can do cross language search. Then there's generative learning. Every data point in the sample is assigned a probability. So we can generate data points. We can generate synthetic text, images, videos, graphs, tensors, so on. And reinforcement learning, there is an agent who is driven by a reward. There is no idea of what we are trying to get as output, but we'll arrive at some kind of optimum solution. Then there's adversarial learning. It's an extension of generative learning. This concept of loss function, your objective function, can be designed with reference to some assumptions on the environment in which learning happens, such as normally stationarity assumption is made. The same pattern which occurred before and the model learned that pattern is going to occur in the future. But this is never the case in the real world. So how do you come up with changes to the model as the data is changing? You come up with a new objective function for guiding the model to the changes in the data. Now, each of these things I'll cover as much as time permits. So earlier we had static embeddings where we want to understand the context of a word to understand the meaning of the word. Not just the syntactic representation, but some kind of semantics into it. And this is represented in a search space. If that search space, you do some kind of what is called feature extraction, you change the search space into a new space. That's called word embedding. And you get some floating point numbers for every word in the context of previous and succeeding words. And if it is done in the context of a neural network, that's neural word embedding. So there is this notion of a vector space, search space, where the neural network is doing the learning. So we have to first create that search space. So what are the ways to do it, and what are the challenges for us when we are trying to create these vectors? So the questions, I put 3 questions. Which linguistic phenomena are captured by word embeddings, such as noun-verb relationships? And out of existing word embeddings, which embeddings are suitable for a particular language, Sanskrit in this case? And what are shortcomings for existing approaches? Now, the answers to this are given by all these word embedding techniques out there, such as word to vector, where the idea is semantically similar words are used in similar contexts. This is encoded into a simple cosine similarity measure. Then there is GLOW, where co-occurrence of words is being analyzed in terms of the frequencies of words in a text. Then there is FAST model, where morphology of the words is being used. Problem here is out of the vocabulary words cannot be modeled. And all these issues are being dealt with neural networks such as CNN, where the convolution operation is used to build the network, and it works at either character level or word level or text level. We define those as the input features for the CNN. And we have to extract those features. The CNN falls under discriminative learning. It is able to predict something from the raw words, such as what will be the next word. And this idea is being formally given in terms of the RNN, LSTM, GRU. These are all sequential learning models where the context of the word is expressed in terms of what is leading up to it and what will come after this word. So I don't give you the diagrams of the architectures of the neural networks. I just tell you the functionality of what they do. Okay, so this ELMO is based on combination of previous techniques: contextual word representation weighted across neural net architecture, and character models using morphological cues. Combine all this to get a robust representation for the word in the deep net. And so we are able to create lower to higher levels of the network, neural network, where lower levels are syntactic and higher levels are semantic. So we are able to extract the meaning out of the text. Now this Albert is based on, this is the latest word embedding. It's based on transformers, which are a generative model. They're able to assign probability to words. So you can generate new words which may not be there in the text which is given, or you can assign probability to next word which is going to come about. And there are different ways you can experiment with the representation of words. So that was discriminative learning using CNNs. And I've taken all these techniques from existing literature, work that is already published. People have already done this, and one can make improvements on it. The second technique listed earlier was sequential learning, which is based on RNN. So the RNN takes a sequence as input, gives a sequence as output. Only thing is we have to define what those sequences mean in terms of our finding meaning from words. This is extended into encoder-decoder models. Encoder compresses all your data into a low-dimensional search space. You just have some variables, some parameters, or some latent variables into which all your data has been compressed. And then there is a mirror decoder using which you can regenerate all your data. But in addition to your original data, you can generate new data. So this is where you can come up with all kinds of fake synthetic data or some data to augment your new old data so that you create a big enough data set for your machine learning. So depending on what you want as output of decoder and the data distribution, probability distribution it follows, with reference to the probability distribution of the original data and the latent data, we can define many data distributions from the training data set which we have. And this is a very useful idea in case of Sanskrit linguistics. So sequence to sequence models was the original version of the same thing. And there are, even after doing all this, we cannot deal with high dimensional data. So this is where Sanskrit grammar, logic, Shastra, things like Vyakarana, Nyaya, Mimamsa, rules can be used to get the latent representation of the text and be able to deal with different kinds of and high dimensional text, which is very noisy. It has many class labels, it is imbalanced, it is sparse. All these issues come up with high dimensional data. And if you are able to encode the grammar characteristics, logic characteristics, etc. of the language into the layers which are representing the text, then you can deal with such data. One way that has been done already is through the attention mechanism, where decoder's output depends on weighted combination of input sequences. So you look at different windows of the sequences, many sequences you take, and then you combine them through some weighting procedure and come up with your sequence to be decoded. This is able to deal with things like long range dependencies in the text. One word is here, after 100 words another word is there. What is the relation between them? But this is only one of the techniques, and Sanskrit can be used like this.
So
now,
will you please summarize in 2-3 minutes?
Okay. So I've talked of encoder-decoder models. So you can apply it in things like cross-lingual representation, used for generative learning. You can also add things like cognition and perception models into the generative learning. And here there is transfer learning, where it is used in things like question answering. Okay, so this is just a lot of text, it goes on and on. Okay, the context of the text is being used to answer the question, such as in bots. And here things like adversarial training can be used on the objective of the learning. Okay, I have already covered this CNN. Okay, dictionary learning, this has been applied to characters, where what is the building block of a character? The strokes which go into the character are learnt at the as the latent variables. Okay, and okay, so we can create something like a graph out of the Sanskrit grammar rule kind of systems and use that graph as the learning input and apply all these different kinds of learnings to do things like question answering. And graphs and tensors are being very commonly used to get a low dimensional representation or contextual representation of data. And there are so many learning models. So for example, I give you link prediction, entity resolution, all these tasks can be solved using these graphs and tensors. Okay. And then we can finally build that AI agent which can do reasoning on its own. And the elements of reasoning such as data, qualifier, rebuttal, all these steps can be put into the graph format. And you can play games with that agent and experiment with your entire knowledge base. Here you have to define, if you are using game theory, things like utility function, which go into your objective function and the solution you are trying to optimize. So there is a whole area called agent mining in data analytics, which can be applied to the representations which we get from Sanskrit text, and then the AI modeling and experimentation which we want to do on it. Okay. So this goes into areas of AI like conversational AI and augmented AI. Conversational AI is task-oriented social robots which are good at responding to whatever query you have. Question answering is an example where agent needs to provide concise direct answers to user queries. Similarly, there are so many other things, task completion, social chat, etc. All this is the AI is interacting with the human. And in augmented AI, you want to come up with this synthetic data along with your original data and create a huge data set which is good for learning. Okay, I think that's it. So I'm okay, sure this is a lot of content. So.
Thank you, Anish. It was a survey of various technologies that are available, which was an eye-opener maybe for many Sanskrit scholars, because so many various technologies are available now and we can use them for harnessing the knowledge from our Sanskrit texts. Of course, as you have mentioned, getting whatever variables you were talking about, parameters, those insights we can always get from the tradition. And that once you have that information from the tradition and use proper technology, it should be able, we should be able to develop meaningful meaningful computational tools or meaningful software for processing of Sanskrit texts. Thank you very much. I'm afraid there is already we are running out of time, so I will not. Are there any pressing questions? Okay, one or two questions. Please, Mike.
Are you also looking at researching teaching learning gaps in Sanskrit?
Yeah, the idea is to invite collaboration in these areas and set the scope for future research problems.
Okay, so my question is, are you actually studying the Sanskrit teaching learning that is happening today and the gaps there and how to bridge them? Is that part of the agenda for your organization?
So I work at BITS. I'm with the computer science department. I don't work with Sanskrit. But I'm just giving you ideas where people can define new projects.
Yes. Actually, my question is that whatever the model you have discussed, so how they are reading those data for Sanskrit? Because in English, every letter have a specific binary sequence and all those things. So ultimately, the models are reading the binary sequence. So in case of Sanskrit, because Sanskrit have so many letters which have half symbol, like so
things like Sandhi.
Yes. Yeah. So how you convert those in binary form?
Yeah, so it depends on the task which you are defining. You have word level and sentence level meaning extraction. You can combine both of them. Because there may be a big Sandhi Samasa, which is a big word.
Mm-hmm.
We can just use the entire word as our feature for the learning.
Okay, maybe.
But there are models just to get the subwords of that big word.
Exactly.
Such as sequential models.
Oh, okay.
Can I make a comment?
Yeah, sure.
So Dr. Amba Kulkarni has done a lot of work on parsing the Sanskrit sentences, the Sandhi Samasa, how to split it, how one can build a tree, and how through Amarakosha one can actually find which section of the world meaning it has and so on. I suggest you take a look at those things and improve or suggest domains where your techniques can be applied.
So I've looked at
all this is not actually Indian knowledge systems at all. This is all Western knowledge systems, whatever you have talked about.
No, I've looked at the publications in Sanskrit computational linguistics, and I've looked at the latest techniques in there. And
but
it uses
none of the
like
techniques are coming from Sanskrit tradition. That's what I'm saying. So
yeah.
That is what
this is
I'm
more
saying.
on the learning side.
So what he has presented is actually a survey of various techniques that are available, and what he has also suggested is we have all this tradition. We look at various language related phenomena or whatever insights are there in this tradition. He would like to apply them. So what he presented is just a proposal. We have all these things. We have on the other side we have our tradition, which is rich in linguistics. So he is actually inviting the collaboration between the Sanskrit scholars and
Especially, what struck me was that in the Sanskrit system, there's this dhatu system, which is actually very much related to semantics, and very systematically one can expand a dhatu and add suffixes to it. All those things should.
So,
but how would you write code for that?
Yeah.
And how would you write a code for it, piece of code for it?
I'll show you a demo later.
Okay. Well, so thank you very much, Anish, and
Yeah.
So I thank, yes, just two sentences, not, I will take just 1 minute. So I thank Dr. Alwar for inviting me here. Actually, I remember 30 years ago in 1994 in Melkote, Professor Lakshmi Tattacharya had organized one conference, and there I saw for the first time the Shabdabodha system, which was developed by some of the team members of your group. I don't know whether you were also involved in that group or not. I don't remember. I don't have the idea, complete information. But I remember even the paper published on that system. And later on, when I decided to work on Sanskrit in 2002 or 3, I contacted Lakshmi Tatacharya and I am thankful to MG Narasimhan, who gave complete system to me, the Shabdabodha system, which worked on the sentences from Bhandarkar's book, some 200 sentences or whatever. So I started with that. So the Sansadhani actually rests on that basic building block, which I took from your institute. So today it was a very nice presentation by 3 speakers. One was on the knowledge representation, how to organize that knowledge. The second one was on learning that is involved, how learning centric systems, how do we develop. And the third one is we have so much technology now, how to harness, how to use that technology for the betterment of our Shastras. So all these 3 presentations were very good. Thank you to all the speakers and thank you very much.
First of all, I thank Dr. Amba Kulkarni for conducting the proceedings in a very nice manner. Actually, it is in the fitness of things that she presided over this session, because she, as she mentioned, from the 2002-3 onwards, for the last 20 years, she has been in this field. So, who better a person than Amba Madam to actually chair this session? And secondly, before we conclude, I'll just take 2 to 3 minutes, not more than that. Because coffee is waiting for us, though we are not waiting for coffee. So, Dr. Anish Chivukula has proposed some collaboration between the Sanskrit scholars and the BITS Pilani to bring together technology and traditional knowledge and try to marry it for a mutually beneficial endeavor. So my request is, you are sitting with 2 stalwarts. One stalwart is Dr. Venkat Subramaniam, who is sitting next to you, who has been in this field for the last 20 years, who is a Sanskrit scholar as well as an information technologist. And then another very important stalwart is Dr. M.G. Narasimhan, who has worked on almost all the fields of the seminar that we are conducting now. He has worked on encryption, he has worked on NLP, he has worked on speech technology. In fact, he was the person who actually implemented the dreams of Lakshmi Tatacharya, to be very honest and he continues to do so. So my suggestion is, you should be more than me, whom I feel myself as a facilitator only. I think you should have discussions immediately with Dr. Venkat Subramaniam and Sri Narasimhan ji, and they will be able to tell us what should be the path hereafter. So I thank you very much, because this session has been, in fact, including the morning session, both of them have been actually action-oriented sessions, in the sense we have something to carry forward, because in Sanskrit there is a saying, Akashe utpanna shabdaha akashe nashtaha. So words come and go, but nothing concrete happens. So I hope something very concrete emerges out of this conference. So I am very thankful to Abba Kulkarni ji. I request Dr. Vidya to kindly felicitate her. So I also thank the other panelists for their very valuable presentations. I will felicitate them. As soon as the felicitation is complete, we will proceed for tea outside and assemble back here at 4:30 for the last session of today. Thank you very much. Please be seated until the felicitations are over. All the registered participants will receive a memento and also a certificate. So that will be given after the valedictory function is over tomorrow. So tomorrow after the valedictory function, I request all the registered participants to kindly collect their certificate and memento before they proceed home. Thank you very much. Now we break for tea and assemble here exactly at 4:30. Only you are having two ಎಲ್ಲ ನಿಮ್ಮ ಸಹಕಾರ ನಮ್ದೇನಿಲ್ಲ ನೀವು ಎಲ್ಲ ಜನರನ್ನ ಕಳಿಸಿ ಮಾಡಿ ಇದು ಅದೇ ಅವ್ರು ಇಲ್ಲದೆ ಇರೋದೇ ತುಂಬ ಹೇಳೋದಾಗ್ಬಿಡೋದು ಏನು ನಿಮ್ಮ ಸಹಕಾರ ಅಷ್ಟೇ ಯಶಸ್ಕಾಯಿ ರೀತಿ ಅವರಿದ್ದಿದ್ರೆ ತುಂಬ ಅವರ ಇದು ಎಷ್ಟೋ ಸತಿ ಅವರ ಕನಸೆಲ್ಲ ನನಸಾಗೋದು ಅದಾದ್ಮೇಲೆ ಆಗುತ್ತೆ 1000 years ಮಾಡಿದ್ರು ಮುಗಿಯೋಲ್ಲ ಚೆನ್ನಾಗಾಯ್ತು ಪಾಪ ನೀವು ಹುಡುಗನ್ನ ಜನರನ್ನೆಲ್ಲ ಕಳಿಸ್ಕೊಟ್ಟು ಇದು ಮಾಡಿ ಅಷ್ಟು ನಿಮ್ಮದೇ ಓ ನಮಸ್ಕಾರ ಸರ್ ಐ ಥಾಟ್ ಐ ವಿಲ್ ಇನ್ವೈಟ್ ಯು ಫಾರ್ ಲಂಚ್ ನೋ ಪ್ರಾಬ್ಲಮ್ ಐ ವಾಸ್ ಇನ್ ಸಮ್ ಮೀಟಿಂಗ್ ಓಕೆ ಸೊ ಟುಮಾರೋ ಪ್ಲೀಸ್ ಡೆಫಿನೆಟ್ಲಿ ವಿಲ್ ಬಿ ದೇರ್ ಅಂಡ್ ನಮ್ಮದು ಸೆಕೆಂಡ್ ಟಾಕ್ ಇದೆ ಹೌದು ಹೌದು ಹ್ಯಾಪಿ ಟು ಡಿಸ್ಕಸ್ ಡೆಫಿನೆಟ್ಲಿ ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಗೋಯಿಂಗ್ ವೆಲ್ ಮಿಸ್ಟರ್ ನಿತಿನ್ ನಾಗರಾಜ್ ನಮಸ್ಕಾರ Venkata Subramaniam, he is head of the Vyoma Linguistic Labs, doing human service for spreading Sanskrit language and all the Shastras. Online platform, this is the best online platform today for self-learning Sanskrit and Shastras. Ashwatha service fund. Nale evening director ಬರ್ತೀನಿ. The valedictory. So you please. Yeah, we'll be there. So Shailaja will also come tomorrow. Okay. Could not come today. Both of us will be there. Nagraj is the expert in mathematics and encryption, etc. So he has done his PhD from London, UK. PhD ಮಾಡಿದಿಲ್ಲ, ಮಾಸ್ಟರ್ಸ್ ಮಾಡಿದ ಅಮೆರಿಕ. ಮಾಸ್ಟರ್ಸ್ ಮಾಡಿದ PhD ಇಲ್ಲೇ ಮಾಡಿದ. BSc ಇಲ್ಲೇ ಮಾಡಿ. ಈಸ್ ಅ ಫ್ಯಾಕಲ್ಟಿ ಇನ್ NIAS. So NIAS faculty that is enough. You need not sit.
Very nicely going on.
Yeah, it's going on well. Beligano.
I was there in the morning or sometime.
Oh, okay.
Turnout the morning was good.
Yeah.
Even now actually fully packed. Okay, see you.
Okay, okay, sir. Sir, ನೀವು ಇವಾಗ ಹೋಗ್ಬಿಡ್ತೀರಾ?
ಇಲ್ಲ, ಇರ್ತೀನಿ.
ನೀವು ಟ್ರಾಫಿಕ್ ಹೊರಗಡೆ ಕುಡಿಯೋದು.
ಕಾಫಿ ಟೀ ನಾನು ಬಿಡಲ್ಲ.
ಇವನೇನು ಇವಾಗ ನೀವು ಹೇಳಿದ್ದೇನು ನನಗೆ ಫುಲ್ಲು ಟೆಕ್ನಿಕಲ್ ನನಗೆ.
ತುಂಬ ಟೆಕ್ನಿಕಲ್ ನ್ಯೂರಲ್ ನೆಟ್ವರ್ಕ್ಸ್.
ಸೊ ಏನು ಮಾಡೋದು, ಏನೋ ಕೊಲಾಬ್ರೇಟ್ ಮಾಡೋ, ಏನು ಮಾಡಬೇಕು ಅಂತ ನನಗೆ ಹೇಳಿದೆ. ನಿಮ್ಮ ಜೊತೆ ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕು ಅಂತ ನನಗೆ ಐಡಿಯಾ ಇಲ್ಲ. ಏನು ಅಂತ ಏನು ಯಾವ ಟೈಪ್ ಆಫ್ ಕೊಲಾಬ್ರೇಷನ್.
ನ್ಯೂರಲ್ ನೆಟ್ವರ್ಕ್ಸ್ ಎಲ್ಲ ಇದೆ. ಇಲ್ಲಿ NLP ಎಲ್ಲ ಇದೆ ಸರ್. ಸುಧೀರೇ ಬರಬೇಕಂತ ನಮ್ಮ ಸುಧೀರ್. ನಾಳೆ
ಆಯ್ತು ಸರ್, ಸಿಗ್ತೀನಿ.
ಇಲ್ಲೇ ಇರ್ತೀರಾ?
ಮುಂದಕ್ಕೂ ನಿಮ್ಮ ಸಹಕಾರ ಬೇಕಲ್ಲ.
ಯಾವಾಗಲೂ ಇದೀನಿ ಸರ್ ನಿಮ್ಮ ಜೊತೆ.
ಸರಿ ಸರಿ. ಇವರು ನಿಮ್ಮ ತಮ್ಮ ತಾನೇ ಇವರು?
ಅವ್ರು ನಮ್ಮ ತಮ್ಮ ಸರ್.
ಶಿಕೆ ಇರಲಿಲ್ಲ. ಒಳ್ಳೇದಾಯ್ತು, ಮಾತಾಡಿಸ್ದೆ. ಸಂಸ್ಕೃತ ಕುಟುಂಬ, ಅದರಿಂದ ಸಂತೋಷ. ಅಪರೂಪ ಈ ಕಾಲ ನೋಡೋದು. ಬರಬೇಕಾಗಿತ್ತು. ಅದು ನಮ್ಮ ಇವತ್ತು ಮೇಲ್ಕೋಟಲ್ಲಿ ಆಳು ಬರಲಿಲ್ಲ. ಅವನು ಹಸು ನೋಡೋದಕ್ಕೆ. ಹಸು ಇದೆ ಮನೆಯಲ್ಲಿ. ಅದು ಯಾರು ಇಲ್ಲದೆ ಮನುಷ್ಯನಾದ್ರು ಬಿಟ್ಟು ಹಸುಗಳನ್ನ ಬೆಳಕ.
ಅವರು ಇಬ್ಬರು
ಹೌದು ಹೌದು.
ತುಂಬ ಚೆನ್ನಾಗಿ ನಡೀತಾ ಇದೆ.
ವೆಬ್ಸೈಟ್ ಅಲ್ಲ, ಇವಾಗ ಹಂಗ ಮಾಡ್ಕೊಡ್ತಾರೆ ಸ್ವಲ್ಪ.
ಟೋಟಲಿ ಎನಿಥಿಂಗ್ ದೇ ಆರ್ ಸ್ಮಾರ್ಟ್. ನಮ್ಮ ಟೀಮ್ಗೂ ಹೇಳಿದೆ
ಸರ್, ನೀವು ಆರ್ಗನೈಸ್ ಎಷ್ಟೋ ಮಾಡಿದ್ದೀವಿ ಅಂತ. ಲೈಬ್ರರಿಲೇ ಇದು ಎಲ್ಲ ಏನಂದ್ರೆ ಸ್ವಲ್ಪ ಕಾಸ್ಟ್ ಎಸ್ಕಲೇಷನ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಮಾಡಿದ್ಮೇಲೆ ಮದುವೆ ಮಾಡುವಾಗ ಒಂದು 10,000 ರೂಪಾಯಿ ಕಡಿಮೆ ಆಗಿದ್ದರಿಂದ ಮಗಳ ಮದುವೆನ ಏನೋ ಬಿಟ್ಬಿಡ್ತಾರೆ. ಇಲ್ಲ 1,00,000 ಪರವಾಗಿಲ್ಲ ಮಾಡಿ.
ಈ ಥರ ಕ್ವಾಲಿಟಿ
ಅದೇ ನೀವು ಎಲ್ಲ ಬಂದಿದ್ದು ದೊಡ್ಡ ವಿಷಯ.
ಒಂದು ಆಪರ್ಚುನಿಟಿ. ನಮಗೆ ಸ್ವಲ್ಪ ಟೈಮ್ ಕಡಿಮೆ ಆಗ್ತದೆ. ಬಟ್ ಯೂನಿವರ್ಸ್ ಆಫ್ ಥಿಂಗ್ ದಟ್ ಯು ಕ್ಯಾನ್ ಆಲ್ವೇಸ್ ಸಿ ದ ಪೇಪರ್ ಆಫ್
ಸರ್, ಇನ್ನೊಂದು ಏನು ಗೊತ್ತಾ ಸರ್, 6 ತಿಂಗಳಿಂದ ಎಲ್ಲ ಆಗ್ತಾರೆ. ಇವಾಗ ಇದು ಅಂದರೆ ಅಕ್ಟೋಬರ್ ಅಂತ ಆಗ್ತಾರೆ. 6-15 ದಿನದಲ್ಲೇ ಎಲ್ಲ ಕೆಲಸ ಮುಂಚೆ ಸುಮ್ಮನೆ ಎಲ್ಲ ಇನ್ನೂ ಟೈಮ್ ಇದೆ ಅಂತಾನೆ ಆಗುತ್ತೆ. ವೆನ್ಯೂ ಬುಕ್ ಮಾಡಿರ್ತಾರೆ, ಇದು ಮಾಡಿ ಏನಂತ ಡಿಫ್ರೆನ್ಸ್ ಏನು ಬರಲ್ಲ.
ಪೇಪರ್ ಬರೆದು ಎಲ್ಲರಿಗೂ ಕೊಡಬೇಕು.
ಇಲ್ಲ, ಅದು ಹಿಂದೆ ಅದು ಆ ಥರ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಇತ್ತು. ಅದೆಲ್ಲ ಓದ್ಕೊಂಡು ಮುಂಚೆನೇ ಯಾರು ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ ಮಾಡ್ತಾರೆ. ಇವಾಗ ಯಾರು ಅದೆಲ್ಲ ಇದು ಮಾಡಲ್ಲ. ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಬುಕ್ ಸಿಗ್ತದೆ. ಇವಾಗ ಇದು Welcome back, everybody. I request Dr. CSR Prabhu to kindly come on stage to chair the session. I request Ms. Sai Chandrasekhar Vaze to please come on stage. Sri Malai Maiti, Sri Devaraj Adiga, and Sri Shankar Ram Sharma. I request all of you to kindly come on stage. So we are late by about half an hour. And we have 4 presentations in this session. So before I hand over to the Honorable Chairman CSR Prabhu, I would like to say a few words. This session is on Sanskrit and speech technology, predominantly Sanskrit and speech technology. A few other subsidiary topics also are going to be discussed. So I, on behalf of the Samskriti Foundation and on behalf of the audience, I welcome all and I'll not elongate my welcome speech. Thank you very much, sir, and I request Dr. CSR Prabhu to kindly take over and conduct the session. Sir, you may kindly. So I request each of the speakers to take about 15 minutes, present their paper in 15 minutes each. And I request Prabhu, Dr. CSR Prabhu to kindly take over and conduct the proceedings.
Thank you. Good afternoon to all of you. Welcome to the last session for today. So the speech recognition, speech generation has been a very difficult task in computer science because the speech morphemes, phonemes have to be recorded from the audio signal coming out of the throat. Whereas in the Paninian system, in fact, if you remember those who studied Panini grammar, Upadeshe, the word is used. Upadeshe, Ajananasika, It. Upadeshas are 5. Varnocharana Siksha is the first one. Then we have Ashtadhyayi, then we have Dhatu Patha, then we have Udadigada. So among the 5 Upadeshas of Panini Maharshi, the very first is Varnocharana Siksha, which is the subject of today. Panini Maharshi has identified the origin of the entire Ach and Hal, Akuha Visarjaniyaha Kantyaha, Ikuyashah Talavyaha, Ruturashah Murdhanyaha, Edaito Kantadalavya Odoto Kantoschyo. So the labials and the palatals have been clearly identified. Even that much was not there in English-based speech recognition because it is all ambiguous. In psychology, P is silent. In daughter, G is silent. All kinds of things happen. So the discipline, Shabdanushasanam, starts with the Varnanushasanam, Varnocharana Siksha. And as you know, the entire 5 Upadeshas make a complete natural language processing system. So the speech was the first part, and my friend Sri V.V.K. Shastri has done a lot of work on the keyboard related to phonetic speech from the Veda Sanskritam University. He was here. So the present keyboard which we use is non-phonetic. The keyboard used for English or even for Kannada or Telugu or Hindi is non-phonetic as compared to a phonetic keyboard. Phonetic keyboard is consistent with the Sanskrit Varnamala, and as you all know, the Varnamala is a more recent invention. It is originally the Pratyahara Sutras of Panini. Ayun Rulruk Evong Ayav Chayavaratlan Jamadanalam Jaban Gadadas Javagadadas Kapajatao Kapai Seshasar Hal. What are these sounds? These are the sounds of the Damaru of Lord Shiva's Natyam in Chidambram. So these sounds were recorded as the fundamental sounds of phonetics of Varnocharana Siksha. And as you all know, Ach means Ayururu Eoyo, Ak means Ayururu, An means Ayu. From first to the last, dropping the last, all the sounds in between. So the entire Ashtadhyayi system is based on the Maheshwara Sutras or Pratyahara Sutras as they are called. Like Vruddhiradaich is the first sutra. At and Aich. Aich means I own, I ouch. So the entire system of Panini is phonetic. It is based upon the Pratyahara Sutras or Maheshwara Sutras. And the speech recognition based on Panini's Varnocharana Siksha will be much more scientific and feasible and successful compared to the Western non-phonetic keyboards and non-phonetic speech recognition systems. So I don't want to take too much time. We'll summarize again at the end. So I request the speakers to start with first is Mr. Sai Chandrasekhar Vaze. Yeah. Mrs. Sorry. She is a PhD scholar from Department of Sanskrit Study, University of Hyderabad.
Before she starts, we have a small formality to complete. We have to felicitate 2-3 persons who have worked for us as they have to leave for some other destination. So I am sorry for the interruption. I request Ms. Vani to kindly come on stage. I am sorry for the interruption. No problem. Thank you very much. Please.
Hello everyone. Should I just stand beside the tables?
Yeah, you can take.
Namaste everyone. My name is Sai Chandrasekhar Vaze and I am currently a PhD scholar under Dr. Amba Kulkarni and I am pursuing my PhD in the topic of discourse analysis. So my topic today is intersentential relations. So what does intersentential relationship means? Basically, we go beyond the simple sentence where in the domain of Western linguistics, we call it compounding and complex sentences. So such sentences where two clauses or two simple sentences get combined, we work on that level. Currently, we are working on explicit level where the markings of these relation in terms of lexical markings and in terms of suffixes are present in the sentence. So we are working on that level. We aim at working on both prose and poetry level where we constrained ourselves to one shloka only. If it has many sentences, then we consider it in our domain. And as we all know, this is the important task in the process of sentence analysis because when we use a language, we get a lot of examples of such sentences where smaller sentences come together and they convey important meaning. And it has many applications which we'll be seeing in detail, such as question answering system, machine translation, information retrieval, anaphora resolution. So when we are done with the analysis, we may move on to such applications. So the first point is, where is this information coded? So we are working on explicit level. That means the information is present in the sentence. So where it is present, as we all know that there is no ready tags or lists available anywhere in where all the information we get at one place. So we search different theories of verbal cognition, that is Shabda Bodha. Then different koshas, such as modern dictionaries, for example, Apte Sanskrit Hindi dictionary, or Anekartha Sangraha, or Vyakaran Chandrodaya. So these koshas and Sanskrit syntax books, such as Shrungara Prakash by Bhoja, or Sanskrit syntax by Spicer. So we had used these books. Apart from that, my senior from the department, Dr. Monali Das, has worked initially on this topic, and she submitted her thesis in 2016. So I'm continuing her work. We created an extensive list of avyayas, that is indeclinables, and all the suffixes that can mark these potential relationships. They have multiple meanings. Each of the marker has multiple meanings, and each meaning is indicated by different markers. So we had made such list. We segregated them into two major categories. We had gathered examples and possible groupings, such as local word grouping, such as api and cha, yatha and eva. So all these avyayas work in group to convey single meaning. So we have grouped these avyayas also. As I mentioned, the information is coded in lexicons or suffixes. So what are these markers? These markers are triggers of certain relationship, which we'll be seeing in the next slides. They are either paired or single markers. Even the paired markers can occur in isolation, but they are pre-coded pairs. These pre-coded pairs have their expectancy with the other pair, and joining of these triggers help us joining of two clauses and sentences, and certain meaning comes out of it. So we had classified these markers into two major categories and many subtypes based on the level of representation and considering their semantics. So these are two major categories. One is correlational and co-referring. So correlational, we can see that there is verb to verb relation. So verb yaha yadi Ramah pathati tarhi saha uttirnaha bhavati. If Rama studies, he will pass. So this yadi tarhi relation calls for avashakta parinama sambandha, and the two verbs are getting marked in such kind of relationships. Whereas in co-referring, there is only marking from a connector to connector, and there is no direct relationship between two verbs, such as yaha pathati saha uttirnaha bhavati. So there is no direct relationship between pathati and bhavati, but there is a referencing or the connection between two pronouns, yaha and saha. So these are correlationals. I guess we are short of time, so I'll just quickly go through it. Purva kalaha, which is precedence, anantara kalaha, succeeding, samana kalaha, which is simultaneity, co-location, where there is samanadhikaranya, sadrushya, similarity, cause and effect, that is karya karana sambandha, avashakta parinama sambandha, vyabhichara sambandha, antithesis or virodha sambandha, prayojana or purpose, and conjunction disjunction, which is samuchaya and anantarya. So these categories and these markers we have identified so far, and we are working on that level. These are some examples. I'll take a few of these examples. The first one is Ramaha Dugdham Pitva Shalam Gachati. So here the suffix tva is the marker, and that marks that the action of drinking precedes the action of gachati. So this insight directly we get from the Paniniya Sutra. Second, if we take the sentence, let's take the example of yadi pathasi tarhi uttirnaha bhavasi. So there is a possibility of if you study, then you will pass. So this possibility or pathanam is the prerequisite of the result getting pass. So this is a relationship of avashakta and parinama sambandha. And the next sentence is yadyapi parvate dhumah asti tathapi vannihi nasti. So this is a typical example of vyabhichara. So we all know the Nyaya Darshana says about Anvaya Vyabhichara and Vyatireka Vyabhichara. So we have combined this into one category, which is Vyabhichara or the hindrance to the cause-effect relation. So, and the apicha, bhiksham atta, apicha gam anaya is the conjunction. So these relationships we have identified. In the second category, as such we have not segregated them into separate categories, but these are pronoun markers, inflecting pronoun markers, which are getting connected with the other. So there is no boundary of person, case and gender, but the number, they should be in the same number. So some of the markings are yadrishi, tadrushi, yavat, tavat, yaha, saha. And as I said, there is no restriction in person, number, gender. In yesham, te, ye, tan. These markers can also be connected. These are the examples. Yaha yat ichhati, sahatat avasham labhate. So yaha gets connected with saha and yat gets connected with tat. Similarly, yadrushi tava ichha, tadrusham karyam astu. So these are the examples. So we had studied the other frameworks also. So this is the Indian grammatical tradition perspective. We have taken some insights from Indian grammatical texts, and we had made this extensive list of avyayas and segregated in them into the categories according to their meaning. But these are two basic famous frameworks who does the same work. One is Penn Discourse Tree Bank and second is RST. So we had studied them comparatively as well. I wanted to make one mark that we are working on explicit level, but Ms. Sukhada from IIT BHU has further is working on the same domain in terms of implicit relationships, and we also aim to move ahead ourselves on implicit relations. So this is a basic comparison chart of our three frameworks. So you can see that the first column, IGT, we have exact mapping to Penn Discourse tree banks and equivalent sentences to RST. In IGT, where we have marked the relationship with bracket or parenthesis, these are the possible relations which can be mapped to Penn Discourse tree bank and RST, and not available is a scene where we have not come across the certain conclusion to it, because most of the sentences and most of the explanations for PDTB and RST tags involve implicit relations. So we have not yet worked on that. So this is the basic background of what we have done and what we are going to do. So right now we plan to move on more semantic approach towards it. So similar tags such as Purva Kalaha and Anantara Kalaha, where the chronology of two actions are getting conveyed. So we plan to uh, make them as analyze them as one. Second, there are dichotomous relationships such as avashakta parinama or karya karana. So in which perspective we are seeing it, that relationship. So the anuyogita pratyogita or the argument 1 and 2, that relationship changes with which perspective we are seeing. So rather than using this anuyogita pratyogita sambandha, we are planning. So this is the future part of it, that we are planning to move ourselves towards uddeshata and vidheya bhavaha rather than anuyogita pratyogita sambandha, and rest of the remaining relations which can go beyond the 2 clause boundary or 2 simple sentence boundary, and anaphora and implicit relationships. We will work it on further, and the application part for it. So this is a very micro topic I have presented so far, and so we were meant to actually present it in the session of NLP, because this is more close to the natural language processing part. And I thank you so much for giving me this opportunity, and I feel like I had least motivation to compare myself with great, but hearing the great sessions from morning, I feel like Titirishudustare Mohat Udupe Nasmi Sagaram. Thank you so much.
Thank you, Sai Vaze. We have Mrs. Male Maiti.
Yes.
Mr. Mr. Malay Mehta is a PhD scholar in Department of Sanskrit Studies, University of Hyderabad.
Thank you very much to the organizer for giving me the opportunity to present here. My topic of this presentation is modeling yogyata for handling ambiguity due to the genitive case marker in Sanskrit. So actually, nyas, os, am, these 3 suffixes are known as shashti vibhakti, that is genitive case marker. And genitive case marker in Sanskrit can mark both karaka relation and non-karaka relation between 2 nouns. The major usages of genetic case marker are classified into 4 categories. That is Kridiyoga Lakshana Sashti, genetic case marker due to Krit suffix. The example is Krishnaha Jagataha Karta Asti. The relation between Jagataha Karta is Kartritva Sambandha. Similarly, second is Upapada Sambandha, genetic case marker due to adjacent word. Gramasya Dakshinatah Vanam Asti. The third usages of genetic case marker is Vishesha Sambandha, that is special relation. Lakshmanaha Raghuvamsasya Shlokam Pathati. Here the relation between Raghuvamsasya and Shlokam is the Grantha, this Adhara Adhya Bhava. And the fourth major relation is Sambandha Samanya, that is Valakaha Matuhu Smarati. Firstly, the Karaka relation in genetic case marker is expressed by due to the primary derivation, that is Krit suffix, and Panini has listed out all those suffixes. And in addition, he also provide the list of adjacent word where the Upavada Sambandha can occur. So in this way, we can get the syntactic clues, and along with that, some semantic clues also for handling Upavada Sambandha and Kridiyoga Lakshana Sashti in genetic case marker. Now, the only Paninian rule that tells us about the Sambandha Samanya and Vishesha Sambandha, that is Shashti Sheshe. Earlier Panini has mentioned in Dhruvamapaya Padanam and Karmana Imamipraiti Sasampradanam, in these sutras, he has mentioned some semantics relations for Apadana, Adhikarana, Sampradana, and apart from that, he collects all the relations and puts in this rule Shashti Sheshe. And in this case, the word can get genetic case marker for expressing Sambandha Samanya and Vishesha Sambandha. For example, this Valakah Smatu Smarati, this is here the Sambandha is Kriyakaraka Bhava Sambandha, and this kind of examples are very less in number. So we focus on the Vishesha Sambandha. In case of the examples are Vrikshasya Sakha Purusha Ragyaha Purushaha Tasarathasya Putraha, and here some semantic relations are expressed by the genitive case marker. And in case of Vrikshasya Sakha, the semantic relation is Avayava Avayav Bhava, that is part whole. In case of Ragyaha Purushaha, the semantic relation is servant master, that is Sevya Sevaka Bhavaha. And in case of Dasarathasya Putraha, the relation is parent child, that is Janya Janaka Bhavaha. In Mahabhashya, Patanjali comments on Shashtisthana Yoga Sutra that there are more than 100 such relation. Ekashatam Shashthyarthaha yavanto va santi sarve shashthyam uchcharitayam prapnuvanti. And this type of relations is marked between two nouns, where the word with genitive case works as a modifier, and Panini does not provide any syntactic or semantic clause to identify this relation. So the problem is identify the semantics associated with this genitive marker in each occurrences, because the relation varies according to the occurrences. And before that, we need to know about the expectancy, that is akanksha. Expectancy, that is akanksha, is a necessary condition for a group of words to form a sentence expressed through the syntax. Actually, it has two types. One is mutual expectancy, that is utthita akanksha, and another is unilateral expectancy, that is utthapya akanksha. Mutual expectancies which are mutual and direct and termed as a niyata or utthita akanksha. This expectancy between var and the words denoting karaka relations is mutual expectancy, and the expectancy that is unilateral or unidirectional is called as utthapya akanksha. This is aroused only if it is necessary. So in case of Vishesha Sambandha expressed by genitive case marker, the expectancy is also utthapya akanksha, that is unilateral expectancy. So and now again coming back to the problem analysis, from the NLP point of view, we face some problem while processing the text. Since Sanskrit is a free word order language and the expectancy of genitive case marker is unilateral, so it creates the overgeneration. For example, Dasarathasya putraha Ramaha nagare hastena brahmanaya dhanam dadati. Here Dasarathasya is in genitive case marker, and since the Sanskrit is a free word order language, so on the basis of utthapya akanksha, we cannot decide that with which word the word Dasarathasya is exactly connected. So now meaning compatibility, that is yogyata, plays the role here. But while modeling yogyata, we face two more problems. That is the first, criteria of yogyata depend on the nature of semantic associated with the related words, and second is there is no such repository of semantic relations expressed by the genitive case marker like Karaka relations. Now modeling Yogyata is the next task. Yogyata in the Indian grammatical tradition defined in two ways. The first is positive definition and second is negative definition. In positive definition, it means a property of prompting mutual relationship, that is paraspara anvaya prayojaka dharmavatvam, and second one is sambandha arhatvam, that is eligibility for mutual association. And in case of negative definition, it is arthabadha, absence of obstruction in meaning. Second one is badhaka nishchaya abhavaha, absence of decisive knowledge in incompatibility. And third one is badhaka prama viraha, an absence of incompatibility. So these two kinds of yogyata leads us the tension between precision and recall. If we focus on the positive definition, it increases the precision, but there is a less chance of type 1 error, that is allowing the wrong solutions. And if we focus on the negative definition of yogyata, the number of possible solutions will be high, but it ensures the less chance of type 2 error. So actually in the first stage we decide to go for the second choice, and these are the reasons. Because modeling yogyata with positive definition, actually it's a huge task, and our first aim is to access the original text. So we want 100% recall, and once we get all the solutions, one can prune out all the irrelevant solutions, and by using the priority. So we have checked 120 sentences from Srimad Bhagavad Gita and noticed that recall was satisfactory, and we came up with some rules with the pair of words to stop the impossible solution. These are some rules. Thus, if the word in genetic case marker is a gunavachana and related with a vyakti or samgya, then this relation is not possible. And second one is, if the word is gunavachana and the related noun is jati, then the relation is not possible. And here are some rules. And along with that, we also note some following concepts from the IGT while modeling the yogyata. That we prepare the list of jati vachaka, gunavachaka and sangya vachaka at the ontological level. We prepare list of gunavachana and sarvanama at semantic level, and we prepare the list of sarvanama apart from gunavachana at the stage of dependency while making this dependency structure. We came up with some notable observations also. Earlier we have mentioned that if the word word in genetic case marker is visheshana, then the relation is not possible. But we have this example, jitatmana prashantasya paramatma samahitaha. Here jitatmana and prashantasya both are the visheshana, but still visheshya is not presented here in this sentence. So we allows the visheshana to make the genitive pair where there is no visheshya in a sentence. And the second observation was, if word with a more than one semantic feature can be a part of a genitive pair. Here the example is mamaivamshaha jiva loke jiva bhutaha sanatanaha indriyani karshati. Here this word sanatanaha is a visheshana. It plays a role of modifier in this sentence, but according to the dictionary it is also marked, it also denotes Vishnu, Shiva and Dharma, and thus we provide we make the relaxation in this context. So we get the 100% recall, and now we focus on the precision. And this time we have noticed that most of the time the head word of a genitive pair is the closest possible noun. Is the closest possible noun in a sentence. The example is tasya sanjanayan harsham kuruvriddha pitamaha simhanadam vinodyochaihi sankham dadmo pratapavan. Here tasya is in genitive case, and the head word of this genitive pair is Harsham, and which is much closer.
Please conclude.
Yeah. So with these observations, we came up with the rule for the high precision, that is, apart from Visheshana, that is modifier, Avyaya and Sadhya Kriya, word in genitive case can take any nearer words as it heads, and we consider it as the first possibility. Other possible pairs will be also provided. So here is the result. Among the 160 slokas, we got only 12 instances where the head word is not closer to the word in genitive case marker. Thank you.
Thank you. So these two presentations were pertaining to grammar and use. And now the next two will be on the topic of this session, that is speech. I request Sri Shankaram Sharma, PhD scholar of IISc, Bangalore, who is actually doing research in, I think, physics, but his personal interest is in this field. We appreciate that. Please go ahead and present your research. So he is working on the artificial intelligence applications in the IISc Bangalore right here. And he is a BTech from Computer Science Department from RVCE. He has been a great speaker of Ramayana and Bhagavata Saptahams, Ramayana Saptahams and Narayaniyam discourses. So it's amazing that a scientist is able to do all this. Please go ahead. Yeah.
Shri Gurubhyo Namaha. Yontah pravishya mama vacham prasuptam sanjeevayatyakila shakti dharasvadhamna anyamscha hastacharana shravanatvagadin pranan namo bhagavate purushaya tubhyam. Namasarvebhyah. This talk that I have here and the next talk by Dr. Devaraj are both very similar talks. Both are on automatic speech recognition in Sanskrit, and I actually refer to his paper. So you can parallelly listen to both talks. Do not think of them as separate ones and put them together. So do not ask me questions, ask him all the questions. Just joking. Nevertheless, I have titled the talk as Mispronunciation Detection, though the basic idea is automatic speech recognition. Because one of the main ideas in language, speech recognition of any language for that matter, and especially for Indian languages, is that we have these Mahapranas, Alpapranas, and we have nasal sounds, as Dr. Prabhu was saying. We have the clear classification in the Varnamala of what is what. And in Samskrita, it is very important, these pronunciations have to be as they are. You cannot use a Alpaprana instead of a Mahaprana, you cannot use a Talavya instead of a Murdhanya. These cannot be done. If you do it, the meaning changes in a very huge manner. So, developing any tool for Samskrita would also help in development of a tool for most of the Indian languages, because all Indian languages are based on this. And as Dr. Devaraj Adiga will show you, they have done the analysis for Gujarati and Telugu also. So, if we give importance to developing a tool for Sanskrit with slight modifications, we will surely be able to do it for any other language, given the data set. So that is our basic motivation for doing in Sanskrit. Many of you might ask, oh, why most of us do not know Sanskrit, why this? But we all, here most of you might not ask, but anywhere else, people might ask this question. So that is our main motivation. The objectives are many for automatic speech recognition. Now we all have these virtual devices, you say, okay Google, and then you talk to it in English. Some of these have, now Alexa has it in Hindi also. But if you want to converse with it in our own language, or ideally in Sanskritam, then we need an automatic speech recognition for Sanskritam. And we want e-commerce, product browsing. And the third point is very important, because let us say somebody is learning Sanskrit and they are learning some stotras, or they are learning to read some granthas. We have teachers, and now as Dr. Venkata Subramaniam was saying, we are moving towards e-learning. And the practice in e-learning has to happen by themselves. You do not have a teacher sitting in front and always guiding them, and this is a mistake that you have done, this is a mistake. And when you are doing it for huge amount of people, you want them to self-learn. So you want model or a tool that actually recognizes that the speaker is making a mistake and tell him this is where you are making a mistake, please recognize this and correct this. This is not how it should be pronounced. So the idea of this tool, though it is not completely perfect now, the idea of this tool is to create a tool where you can help the learner say that you have made a mistake in this particular Mahaprana, in this particular Akshara, you correct it. It will not be able to say the correction of now, but probably in future it will be able to say it is not the, it is the, it is not ba, it is pa. All these corrections it will be able to say in future. So that is one of the main objectives of this tool. And then improved transcription of all audio books or lectures in Sanskrita. All these are also a corollary this thing. So for pronunciation, this I am sure you just see the cartoon and you are going to understand what it is. No Alexa, I said order lunch, and then instead of lunch, it assumed that it ordered a launch and it has launched the rocket. So you do not want such mistakes to happen from your assistant, right? In Samskrita, you have the Tasmat Pataputra Vyakaranam, Sakala Shakalo Mabhute, Sakalam Shakalam Sakrit Shakrit. So we need to understand the differences between them, and the tool should be able to identify this difference. That is why pronunciation, and here in English, enunciation is important. It is not lunch, it is not launch, it is lunch. So the conventional limitations of ASR, we have some models that have already been proposed, and some models that have been by Professor AGR in IAC itself. So previously how models used to be done were there were 2 or 3 separate models. One is the pronunciation model, then there is a language model, and then there is an acoustic model. You put all these 3 together and then you create a model. So a language model would say what are the what things can happen in the language and what are the n-grams, the probabilities of the word that occur next to each other, and so on. Then the acoustic model would take all the audio signals and process it and say this is the kind of audio that could be had in this particular language, and the pronunciation model would have the particular language's pronunciation. So all these 3 models have to be integrated, which itself might not integrate very well, or they might cause some problems in integration. And the sub-models require some specialists for that particular saying. You need a Sanskrit scholar to say the language model. You need a Sanskrit scholar for the pronunciation model. So these things are some kinds of limitations. Now we all know things like ChatGPT exist, and from 2017-18 onwards, we have what are called as transformer models in deep learning. All these are able to do it without such specific features being fed into the model. You give the language, you just recite some verse and you give it in, it is able to extract features. We do not exactly know what features. You should assume it's a black box, though mathematically there are a lot of things behind. And in the next few slides, I am going to go little into the mathematics. Do not get scared. Just assume that there are images on the slide, and then I will explain to you some parts of it, and you can just grasp it in, and then you can just assume whatever is there is there. That's all. So most of it, whatever happens in computer coding nowadays with this kind of AI is, as Professor Anish explained, there is a lot of black box that happens inside. So most of the computer scientists and people who are coding also do not really care what's happening behind it. And so I am going to go into a couple of mathematical points. I will try to explain it in layman's terms. You try to understand so that you know that these kind of applications can be made with Samskrita also, and we can take it forward in many different directions. So that is why I want to go here into a couple of slides in mathematics. So enter here is end-to-end speech recognition. Instead of having 3 different models or 2 different models, we have one model that just takes in your speech. You give an audio file, it takes it in, and then out comes your output. You do not have separate models inside. So that is the end-to-end speech recognition. How do we do that? Using something called CTC, which is a connectionist temporal classification. We will see what the CTC is, and we will see how this whole model is structured. So the advantage of CTC is that it offers monotonic alignment. You give a speech and you have some probabilities, both of them are monotonically aligned. You don't need to build separate models. You integrate all feasible input-output alignments. So given a text, there are many possible alignments that could be generated between your audio and the text. Let us say there is a text and there is an audio. There could be many alignments that could be made. So this chooses the best among those alignments, and forced alignment is not needed to supply training labels. Do not worry too much about this. These are technical terms. Let's go to the next. So assumptions of CTC is that the alignments between the x and y. What is x and y? I will show it to you in the next slide. They are monotonic. The alignment between x and y is again many to 1, and the length of y should be less than or equal to length of x. So, these are some assumptions that we assume, and these are allowed assumptions. These are not constraining assumptions to say so. These are basic assumptions that we can work with. So, the math behind this CDC is this. So, the input feature vector is x. So, what is an input feature? Your input to the model is your audio. Let us say you say dharma kshetre, kurukshetre, samaveta, yuyutsavaha. This is a 4-second, 5-second input that you give to the model. Whenever you give some input to the model, in a computer, as we call it as a model, it is not going to go as audio. Our brain processes it differently, but in computer, anything is input in the form of numbers. So, this whole thing is an audio signal. You have some numbers, the whole thing is a time series thing, and it goes in. Then there is a conversion that happens from just the audio signal. We create a set of features called the MFCC features. MFCC is Mel frequency. We create those features and we feed it. So, this X is actually those MFCC features. So, let us say that audio is there, it is converted into numbers and given to the model. So, you have some set of numbers that are given to the model. Next, your output sequence is your Y. What is Y? If I say dharma kshetre, my output should actually be dharma kshetre. My input is an audio signal, output is the text dharma kshetre, dharma kshetre. So, this is my output. Y is the text, X is your input audio signal. So, V is your labels, that is A, I, E up to all the 54 varnas that we have in Samskrita, it is the labels. So, that is V. So, X is input, Y is output. So, that much is clear. Now, consider a path that is Z. Given this whole audio file, I could have, let us say my model was hopeless, and when I say dharma kshetre, it translates it to samavetaha. Okay. So, that is one path that my output could take, but dharma kshetra is the right path. So, these different paths that are allowed is denoted by Z. So, Z is a path, Y is output, X is input. So, given these probabilities by Bayes theorem and by some other time assumptions of time distribution something, we can say the highest probability of the path is what should be selected given a set of input features. So, that is what is happening here. Okay. So, the idea is given multiple mappings to my input this thing, I choose the path which has the highest probability. So, this is what the whole idea of CTC is, right. So, this is how a deep neural network would look. A lot of you would have heard what deep learning and AI and a lot of things. So, AI is a very huge term, but deep learning is a term where you have a lot of neural networks coming together, and one of them, this is one of the neural networks that we have used, and this is my input. As you can see, there are 128 MFCC features. Given whatever sample of audio, I would create 128 numbers and input it. Then you have something called the convolutional layers, which is also referred to by Professor Anish, and then you have something called bidirectional GRU layers. Anybody who wants more can revert back and we can discuss about these things. And then you have some fully connected layers, and out comes your output. So, this 54 are the 54 letters of our Samskrita Varnamala. Why 54? Again, is it 48, 51 and all? We have 54 in that encoding, so 54 is the output. Right? So, 54 is our output, this thing. So, let me explain only this convolutional layer so that you all understand what could be happening inside a neural network. Or else this whole thing is basically a black box for any person. You just put some input, you get your output. It's as simple as that. But what's really happening inside? Let us look at only this part, because explaining these will take quite a long time. So, I will explain this part to give an idea of what really happens. So, convolution, so as I said, any input is a set of numbers. Let us assume the numbers are a matrix. Okay. You can see a matrix of numbers 1, 1, 1, 0, 0 and so on. This is a matrix. Now, you have a smaller box in a different color that is moving like a window, as you can see, and there are smaller numbers within that. Let us multiply the smaller box numbers with the numbers that already exist, right. So, let us say the smaller box has 1, 0, 1, and you multiply the first 3 numbers, you get 1 plus 0 plus 1, and similarly you multiply that whole 3 by 3 box, you will get a feature called 4. Okay. It is just a simple multiplication, 1 into 1 plus something. So, it is simple multiplication and you will get something outside here. So, that is called a convolved feature. You see, this whole box is moving and one feature is generated by one multiplication of this box, as you can see here. So this is called a convolution. This happens on those set of numbers that are generated from the audio signal, and this moves forward and you get a lot of things. So this is how some workings inside the neural network happens. This is like 1% of what's really happening there, to give an idea of how many calculations are happening. So neural networks or artificial intelligence is all about just mathematics and multiplication of matrices, and that's all it is till today. So there is no real consciousness behind it, as we saw in the first session. It's just multiplication of matrices from starting to end. How the multiplication happens, it may be in different ways. There is some differentiation, something that happens. But when we say learning in the context of artificial intelligence, it is differentiation. When we say something else, when we say consciousness, it is just multiplication that's happening. So there is no real consciousness that has been developed, whether it is ChatGPT, whether it is Google search, or whatever it is. All these things are what is happening inside them. So this feature extraction, as I told you, there is something from the audio. We extract this MFCC. We have the data that is sampled at 22,000 hertz, and we have a window length of 25 milliseconds along with a 10 millisecond hop length, and we have 128 features. So whether you give a 5-second audio or 10-second audio, currently our model converts it to 128 numbers, that's all. So we can improve it if we have, let us say, always we take a 5-second audio and always we have a 128 number, we can improve the model. But currently these are the limitations. And we use some data augmentation techniques which are well known in the literature. We will jump to the results. So we have two different kinds of encoding. One is IAST, which you all will know, and the SLP1, which will also be shown by Dr. Devraj. And we have what is called the character error rate and the word error rate. So character error rate means for every character, if the character is given correctly, then it is correct. If there is a different character, or if the character is deleted, or a new character is inserted, then there is a mistake. That character should not be there. Either there could be an insertion, deletion, or a mistake. So three kinds of errors are possible. So putting all together and with a simple mathematical formula, you get the character error rate. And you have a word error rate. So character means it will calculate character by character. In a word, it will take the whole word. So even if one character is wrong, the whole word is wrong. But when you do each character, it is different. So that's why you see the character error rate is quite low at 4%, and the word error rate is almost at 34%. I will show you the real decodings in the next slide. That is for the IAST. For the same SLP encoding, we have 9% error rate at the character and around 47% at the word error rate. This looks hopeless. When you say 47%, half the words are wrong. What is the use of my model altogether? But if I show you the decoding, as I said, even if one letter is wrong, it says the whole word is wrong. So, and currently the data set that we have used and what Dr. Adiga has used are the same. It's about 78 hours of recording that we have got from various sources. So the main issue here is the data. 78 hours is very, very less. The models that English is trained on has like millions of hours of data. But for Samskrita, you do not require millions of hours of data. If you have even 1,000 hours of data, I am sure we can get this down from 4% to like 0.01% or something like that. Okay. Because, as Professor Prabhu mentioned, we have a clear phonetic this thing for Samskrita language. So the mapping is straightforward. You do not need something like, as he said, psychology to P. There is no P there, but psychology has a P. That will never happen in Samskrita. So you need lesser amount of data, but we still do not even have 100 hours of data. We are working with like 78 hours. We have some data from Vyoma also, which we put together. So we have very less amount of data. So the same model, if you are able to train it on about 500 hours of data, it's going to drastically improve. So do not be thrown by these bad numbers over here on the slide. So let us say one of the decoded predictions, just for an example. You have the first prediction, which is exact. Ragapugan Sarpa Brajan. Okay, that is clear. When you come to a long word like this, Ghora Dhvanita Shravana Janita Bhaya Vashat Diganta Tadantinopi Shushka Mada Jalataha Jataha iti Bhavaha. Here you see Ghora Dhvanita has been Ghura Dhvanita. So Okara has become Ukara. And similarly, the Nakaras next to the Ta have become Makara here. So those are small kinds of mistakes that this model is making. So we know where the model is making a mistake now. So we can probably train it on only these kinds of data to improve the model performance. Similarly, you see here, wherever the Nakara has been thought of as Makara, that may be because the data is small and that person who has recorded might not have that good a pronunciation. Though what we have are really good people, but the recording itself, the clarity of the recording and all that comes into picture here. So Nemayaha has become Memayaha, and there is a character missing here. Nishwasanaischa, Hakara is not there. That Nishwasanaischa, Visarga is not there. So such small mistakes. On the whole, if you see, you don't think this is a 47% error rate is not there on this, right? But that is what the calculation on the average, that is calculation, because if you make one mistake here, this whole word is gone. But character error rates are quite low, and if we are able to get 0.01% character error rate, we hope this can be helpful for learners to detect mispronunciations and learn the language better. So the effect of the length on the words. So the length of the word, if it is just 2-3 characters, your accuracy is like 90, higher than 90%. As you go to 30-35 characters, our accuracy drops below 20%. This is the word accuracy, for example, not the character accuracy. As you see, there is a clear, as the length of the word increases, this thing keeps reducing. Because obviously the number of words that have this length is also less. So my data has not seen long words many times. So this can be dealt with in different manners. We can cut the words and probably do it. But all this should be solved if we have enough amount of data. All this will be solved. So we need not really look into this. But this is what we really anticipate also. It should reduce like this. And in my data set, the number of words that have this length this is the histogram of the number of words that have this length in this data set. The number of words that have short lengths are more. A number of words that have beyond 30 is hardly anything. That's why my testing also is hopeless.
You need to conclude.
Yeah. So thank you. So any other questions, we can have a discussion later, and Dr. Devraj will continue in the same vein. Thank you, Varuna.
Yeah.
Dhanyavadaha. Namasarvebhya.
Devraj Adiga to continue the story of speech recognition. Wait. At the end we'll have questions.
प्रणम्य दक्षिणामूर्तिं विद्यागणपतिं तथा सरस्वतीं परां वाचं वन्दे वागर्थवित्तये. I am thankful to the organizer for this great opportunity, and also I am thankful to the professors from our institution and also to my collaborators. So we already had a great introduction how this ASR works and what is the motivation behind this and all. So I will skip through that. So as we know, as mentioned by him, there are 3 major parts in an ASR system. In case of cascaded ASR system, whereas end-to-end model, where we can directly input the labeled speech data and the model can automatically learn the features and give the output. So when we come to see the barriers, especially in case of Sanskrit, the number of unique words is always very high when compared to other languages. As the number of words increases in the corpus, so this remains always high, especially in case of Sanskrit, as we compare to other Indian languages and also English. So this results in the higher rate of rare words in case of Sanskrit, resulting higher number of out of vocabulary words. So these are the major challenges when we want to design a ASR system for Sanskrit. So as he mentioned, the labeled speech corpus is not available. So when the ASR research for Sanskrit started during 2019, the first attempt which we saw, the published attempt by AGR from IASC, so they used only 3 hours of data. So then So even though, as we know, it follows phonemic orthography, especially in case of Sanskrit. So whatever we write it, we pronounce the same thing. But still there are problems due to the morphological richness of the language. So people might have heard from the Mahabhashyam that Brihaspatirindrayat Pratipadaoktanam Shabdanam Divyam Varshasahasram Shabdaparayinam Provacha Nantam Jagama. So Brihaspati taught Indra the words for 1000 Divya years, but still it did not end. So that's how the grammar gets evolved after that. And also, when we go for conventional cascading models for ASR, the word level modeling choices deteriorate the performance. So we need to find out the solutions for that. And also, number of native proficient speakers are very less. So coming to our contribution, so we developed a speech corpus of 78 hours, which already introduced by Sharma ji, and for addressing the problems due to the error rates, higher error rates, which is coming out of word level model. So for that, different acoustic models we present, and after that, for improving the model further, so we incorporate morphological information along with the deep learning model, so that we can improve the performance much more better. So already some people have mentioned in the previous lectures that the problems which exists in Unicode encoding system for Indian languages. For example, if you take a word like Vagartha Viva, so there is no one-to-one mapping between a phoneme and a grapheme. Similarly, the Halanta joiner which is used, so it is not having any phoneme associated with. So to address this problem, we use SLP1 encoding, where there is a one-to-one mapping between a phoneme and a grapheme. I will skip through these. Yeah, and the major thing is the problem arising out of Sandhi. So we know that due to Sandhi and Samasa, the word length can grow to any level. So if our great scholars like traditionally trained scholars like Dr. Alvar, so they can do the Nyaya Parishkara for words, so which can be running for many lines. So for example, if you take one word like Nitya Shabdartha Sambandha, so it can be pronounced by Nityaha Shabdartha Sambandha. So one who is not that proficient, he can pronounce it as Nityaha Shabdartha Sambandha. So he can give a pause in between. And similarly, a pause can be between irrelevant places. Nitya Shabdartha Sambandha. So such cases also we can see when we go through the corpus, when we analyze the corpus. So when we come to the speech in case of Samskrita especially, so two kinds of things we can see. One is Padya part, another is Gadya. So for Padya, different people use different tones. So that will be one more level of challenging task. So currently we are focusing on Gadya part only. So we took many things into mind when we created the corpus, so that it can be chronologically, topically, and stylistically diverse. So these are some of the works which is used in the corpus. So we can see that it is ranging from time of Mahabhashyam to the contemporary discourses, extempore discourses, the books published by Sanskrit Bharati, Katha Lahari, or Sambhashana Sandesha, etc. So and totally there are 27 speakers, including both female and male speakers. And when we perform the experiment, the speakers in training test validation set, so all of them should be disjoint. So it should not be overlapping with one another. So we created one more special data set in this, that is out of domain data set. So which may not be in accordance with the rules given by the Shiksha. So for example, people from Hindi background may give short deletion. For example, Arjun, so Arjuna Uvacha can be pronounced as Arjun Uvacha, so like that. So we wanted to see how the system can perform on such a data set, and also extempore discourse, live lectures kind of thing. So as I mentioned, we also experimented on SLP1 along with the Unicode representation when we performed the experiments. So when we perform the experiment, we see that word level system will give very bad results. So ranging up to some 40% word error rate. So what can be the solution for that? Can we go ahead with a Sandhi splitting method? For example, if we take Ramaya idam as Ramaya idam, so in such cases, one more problem arises. So there won't be mapping between the transcript and the speech. So we can't go ahead with this. So therefore, we use a BB-based word segmentation approach. So this is a purely statistical approach, which is basically used for data compression algorithm. So recently it is used for machine translation and all. And linguistically motivated approach we also proposed for this. For example, the Laghu Guru mapping, if you take Anyani Sunyati, so based on Laghu and Guru, we can group the syllables. But if we directly go for the syllabification, for example, if we take Sachit, so it will be splitted as Sa-chit. So the word boundary won't be retained in that case. So therefore, we slightly modify that splitting approach. So it is splitted as Sach plus Chit. So in, of course, there may be a few false positive, but most of the cases we retain this word boundaries and all. For example, if we take the example Udyanaha, it is split as Udyanaha. So this is the data set which we use for Gujarati and Telugu, which we compared our approach. We used the data set released by Microsoft, and the model which we used is using Kaldi toolkit and TDNN model, so which is one of the very famous model used for acoustic modeling. So these are the results which we got with the different experimental setting, and the best performing model gave the 21.94 word error rate, whereas character level error rate we got 3.1%. We compared the results with Gujarati and Telugu also. So here in this case, word level models are performing much better. So of course, there are few things which we can observe, that in case of Sanskrit, OOV rate is very high when we compare with Telugu and Gujarati, and rare word rate is also very high, and continuous consonants, so which is more than 2, is much higher than Telugu and Gujarati, and also average word length once again is high.
Let us conclude.
Sorry?
Let's finish.
Okay, sure. So these are the results for out-of-domain data set which we described. And then we go for post-processing using morphological information and energy-based model. So basically we take the n-best output from the ASR model, and from that we generate the subword WCN, and from that we form the fused word confusion network, and then we enrich the search space with the morphosyntactic information generated from SHR, Sanskrit Heritage Reader, and then we score that with the we score the each edges in this word confusion network, and then we get the final result. So with this we could able to achieve up to 12.54 word error rate, and we compare this with one of the latest end-to-end model, that is Wave2Vec. So in that, when we fine-tuned the model using our data set, so we could able to achieve up to 20.17 word error rate. Yeah. Sure. So these are the out of vocabulary words which could able to recognize by the systems with phoneme length up to 46. Yeah, thanks to everyone.
Thank you, Adiga. So I think we have come to the end of this session. We have one or two questions. Shall we?
Just one or two maximum.
Yeah.
Any questions, please?
Yeah. I think Ambaji wants us. Please go ahead. Yeah.
This is just a curiosity for Shankar. You mentioned that you have evaluated the system with IAST and SLP, and with SLP the error rate is more and in IAST less. I just want to know why it is so.
So one is the same question arose with us also when we started off. One is, I think because it's an end-to-end model, we cannot completely describe, take that at face value, because as you saw in the end results, both are very close. That 47% is a kind of outlier, which really is not the case. And SLP has, for Vedic swaras and other things also, it has its notations, which are not there in our this thing. So it is, maybe it is taking that also into consideration, therefore there is a little bias in the data set. To SLP1 and our data set is not clearly mapping, whereas IST has a better mapping for the current data set. Maybe if you use SLP1 on a Vedic data set, it will surely perform better than IAST in my opinion. So I think that is the difference.
Because IAST, as far as the Devanagari alphabet is concerned, whether it is IST, SLP or the WX which we use in IIT Kanpur, which was originated, all these are one-to-one mappings. Correct. So I was curious, but then if the data itself is not Vedic data, then that SLP Vedic part also should not matter.
Correct.
Right?
You are right. that should not matter. But I think because we have in the end output vector is a 54 labeled vector, and the probabilities of each of the output node is not equivalent, and therefore I think the softmax has problems. The mic. Switch on the mic.
Can you hear me now? Yes. So you had this character error rate and word error rates, and the word error rates were very high due to and then it started becoming less when the length of the word is less and so on. The problem is the definition of the thing called word itself. Correct. So like, for example, there's a famous one Tirumalamba longest word length in Sanskrit, which if anybody tries to pronounce it, probably somewhere they'll get some error. So that will become one word which is an error and so on. you can't have this kind of a definition of a word is what for example, if the passage itself becomes one word, then you will, if the passage, something is wrong in Vishnu Sahasranama, you'll say entire Vishnu Sahasranam is wrong, right? So that kind of a definition problem you have. How would you expect to
I agree.
tackle it?
That is why we concentrated more on the character error rate. So let us say there's a long word. My output might actually give spaces between the word, and it might still predict very close to what is there. But since the output is 3 words and the input was supposed to be 1 word, so it thinks there is a 3 word, there's an insertion of 2 extra words. This is what the formula would think. That is why we concentrate more on character error rate, or we should sit down and think of giving a new definition for word error rate. And as he said, we should work on that Samasa and Santi split and see whether we can do something better.
Thank you.
Thank you very much. I'm sorry we are running out of time. We can continue the discussion outside the auditorium. We are supposed to close at 5:30 but it's already 6 and the staff of NIAS have to leave. So I am sorry for the curtailed discussions. And this panel of about 4 people who have presented, they are all youths and they are going to become stalwarts in their fields. So I thank all of them. So it has been a session of the youth, and they are going to take forward the mantle of getting together science and technology and also traditional knowledge. So I thank each one of them. I will not tell their names separately. So thank you all for the nice presentations, and thank you all for the patient hearing and active participation. I now honor them. I have the opportunity of honoring them. After that, just 2 more small announcements are there. After the announcements, we conclude for the day. I also thank Dr. CSR Prabhuji for chairing the session and conducting the session ably. Now we have to another very important aspect. Felicitate the volunteers and others who have helped us organize the program. So I request them to come one by one. Shri Narayan Prakash, please. So Narayan Prakash has helped us organize all the on-stage activities. Dr. Hemant. NC Srirangraj, who has been manning the online feed that is going live on YouTube for morning. Dr. Sri Ganesh, please. ರಮೇಶ್ ಅವರು ಇದ್ರೆ ಬರಬೇಕು. ರಮೇಶ್ ಅವರು, ನರೇಶ್ ಅವರು ಬರಬೇಕು. ಮಿಸ್ಟರ್ ರಮೇಶ್ ಫ್ರಮ್ ನಿಯಾಸ್, ಪ್ಲೀಸ್. ಹಾಗೆ ನರೇಶ್ ಅವರು ಬನ್ನಿ ಪ್ಲೀಸ್. Miss Amulya, please. Miss Rekha, who has spared no efforts to make the conference a grand success. She is the organizing secretary. And Miss Indu, who has also been the assistant organizing secretary, actually burning the midnight oil many times to make the function a grand success. So I am extremely thankful to all of you for your active participation. And in Sanskrit there is a saying, Shateshu jayate shuraha, sahasreshu cha panditaha, vakta dasha sahasreshu, shrota bhavati vanava. Among hundreds we find a very valorous person. Among thousands we find a scholar. Among 10,000s we find a speaker. But it's very difficult to find a listener. So we have listeners in abundant number, and I just say, Bhuishtamte namauktim vidhema. Thank you all for your active participation. I request you all to please be assembled here by 9:45 tomorrow. The sessions will start exactly at 10 o'clock. And as usual, we have 2 sessions in the morning. After lunch, we have a panel discussion by a very expert panelist will be addressing the panel, and we want to make it an action-oriented seminar because we want to take forward the tasks that have been discussed, and we have quite a big agenda to be taken forward. So we have the panel discussion, and after panel discussion we have a tea break, and then we have a brief valedictory session, which will be attended by Dr. T.G. Sitaram, the Chairman of All India Central Council for Technical Education, who will be giving the valedictory address. We will also be joined by Tejasvi Surya, a very eloquent speaker and Member of Parliament from Bangalore South, and several other dignitaries. So I request all of you to join us again for the session tomorrow morning at 10 o'clock and have a very mutually rewarding session. Thank you very much. Namaste.